Very good evening, very good evening. Very good evening to all of you to the most fabulous lecture of Alkane, saturated hydrocarbon. So today we are going to deal with the best lecture. So welcome to all of you to yours Unacademy NEET English channel. So today really we are going to start with the fabulous chapter, that is your hydrocarbon, and the first chapter alkane. And in this alkane, okay, let me tell you, but before that, whatever I'm going to let you know, before, let me know in the chat section, everyone, can you hear me, can you see me? Everyone, show me the green signal, you know the drill. If I'm perfectly audible and visible to all of you, show me the thumbs up or the green hearts that yes, you can perfectly see me, hear me. Oh, really, Avengers and the Conquer Batch, both of you are over here to the most fabulous lecture, that is being your alkane. And kids, along with the reactions, before starting reactions, definitely I will tell you the basic, the hybridization, the shape, each and everything, because number of students are there, those who don't know about how the compound is formed. Vidya, very good evening, welcome, vanakkam to each and everyone. Vidya ji is there, King Live is there, Arthi is there, number of students are there. So kids, what I was telling you, in this hydrocarbon, that is being your alkane. You know, alkane, the first chapter of hydrocarbon, yes, it holds a hell lot of weightage in your organic chemistry. But I will move with the sequence of NCERT. I'm going to follow each and everything, whatever is written in your NCERT. So, yes, last session's PDF. Okay, Color Science, I think you haven't got the last session's PDF, GOC Part 2. Those who have not gone through GOC Part 2, please go through it. And definitely that the most basic thing, or you can say the most important thing for your organic chemistry. Anyways, kids, so let's start. King Live is there, Color Science is there, Sonal Verma is there, Jashan Preet is there, everyone is there. All those serious students, those who are really going to get the best rank in their NEET exam of 2024 are present over here. Welcome, welcome, welcome to each and everyone. So, if you don't know who am I, let me tell you myself, Haren Singh Parihar, your HSP Baba. I did MTech in 2004 and MSc in 1999, gold medalist, that is topper, right? And after MSc, GRF and GATE, I have qualified. Now kids, if you are new to this channel, like, subscribe also. And everyone, it's a humble request, everyone smash the like button. Yes, hit the like button and just show me your energy that yes, everyone is ready. Everyone is ready for this lecture, super awesome lecture. Some students are saying they're first class. Yes, this is the first class of hydrocarbon. So see, this is drawn by, see, this slide I have taken from any site, or what do you think? Your HSP Baba has drawn this figure. What do you think, kids? Do let me know. This is your methane. I have drawn this figure, or I took it from site. Do let me know. Let's see what's your guesses. HSP sir has drawn. Kids, see, HSP sir has drawn. Now see, this is the structure which you are studying from your class 10th standard, that Lee von Top has given this structure. Lee Van Hoff has given this structure that this is methane and the bond angle of each is 109 degree. Now kids, how this methane got formed, I'm going to tell you each and everything from the very beginning. HSP Baba did it. Okay, thank you Priya Paul, Dakshini, Esther, Nandu, really awesome, really awesome. Now see how this methane has formed. Let me tell you from the very basic. See, methane formation. For your methane, we need carbon. And carbon is, you can say carbon is the king. Carbon is king. If I talk about organic chemistry, carbon is king. Now, carbon is having 6 protons. 6 is the atomic number of carbon. See to it. Everyone see to it. Carbon's atomic number is 6. In class 4th, we were doing like this 2, 4. But in your class 11th, once you are going to study your atomic structure, definitely your sir will let you know that advanced electronic configuration 1s, s orbital can hold maximum of 2 electrons, then 2s, this can also hold maximum of 2 electrons. Whatever is s is the subshell, where subshell is present. Kids, where subshell is present, let me tell you. If this is your nucleus, if this is carbon's nucleus will have proton 6 and neutron 6. Your Vasim sir, our Vasim sir must have told you that carbon is the most stable isotope. Yes, and carbon 12 is the most stable isotope of carbon. So this is carbon 12. And if I talk about the first orbit, first shell of carbon, second shell of carbon, third shell of carbon, fourth shell, fifth shell, infinite shells. So in this shell, just like the sun, then Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, like all they are moving around the sun, like our galaxy, like our planets. So the atom is having nucleus and this shell. Shell is the imaginary part around the nucleus in which electrons are moving. And you know that in shell there is subshell. Subshell, the first shell is having 1s, the second is having 2s and 2p also, 2p. Second is a little bit bigger, it is having 2s the subshell, and this subshell, the p subshell, is having 3 orbitals. Now see how many electrons are there in carbon 6. So 1s2, 2s2 and 2p2. 2 plus 2 plus 2, 6. So 1s2, 2s2 and 2p2. This is the ground state electronic configuration of carbon. Kids, till now everything is clear. Yes, everyone is getting each and everything. Is everything you are getting in your brain that there is nucleus, zoom, around the nucleus electrons are moving. Now the path by which electrons are moving are known as shell or orbit. This is shell or orbit. This is shell, or you can say orbit. Just like there is our Asia. In Asia there is India. In India there are states. So there is shell or orbit. In shell there is subshell, S subshell, P subshell. Now S subshell has orbitals. This is having only 1 orbital and this is having 3 orbital, and each orbital is like box of shoe. Orbital is like orbital is like box of shoe, or you can say sandal. Sandal. Now let me know, one shoe can contain maximum of how many shoes? One shoe box can contain maximum of how many shoes or sandals? So each box can contain maximum of 2 electrons. Maximum of 2 electrons. This is shoe box, this is shoe box, this is shoe box. Okay. So this is the electronic configuration, and I would like to say this is the ground state. You know ground state? If I say the ground state configuration, just like if I'm in my ground state, see, look, just look, I'm in my ground state. Oh, I'm walking towards my coaching. But in front of me, there is one elephant running towards me, just like Bahubali movie. You must have seen in Bahubali movie, elephant was started running. So if elephant is coming towards me, what I will walk like this? Yes. Should I walk like this, or I will start running? Just do let me know. I will remain in my ground state, or I will start running. Gorilla. Oh, King Life has seen gorilla. Okay, I will start running. That means in ground state, I will have less energy, and in excited state, I have to spend some energy. That means whatever is the configuration in ground state. If I talk about the electronic configuration of carbon in ground state is 1s2, 2s2, 2p2, and if I like energy wise, if I draw it energy wise, I will draw it like this. 1s2, this is nearest to the nucleus, this is nucleus, then 2s2, then 2p2. This is the energy is increasing. Energy is increasing. Now, this is the configuration in ground state. Ground state configuration, electronic configuration. Till now, it's clear to each and everyone. Now, if we provide some energy, on getting some energy, if it is getting some energy, then what will happen? But before giving energy, let me draw it orbital and subshell wise. Wait, let me draw it orbital and subshell wise. This is 1s, this is 2s, and this is 2p. Now, let me tell you, this is having 2 electrons, 1s2. This is also having 2 electrons, 2s2, and this is having 2 electrons. Now, kids, do let me know, for carbon, which is the last shell, which is the filled. Last filled shell is 2s and 2p. This is the outermost filled orbit. Outermost filled orbit in ground state. Till now, everyone, are you able to get it what I am writing? Say, always show me the thumbs up if things are clear. Kids, I'm just starting from the zero level. From zero level, I will reach up to the top level, whatever is required for your best rank. Till now, it is clear. Now, if I provide some energy, if energy is provided, you know, all the soldiers, when they are in their company, they are just silent. But once they are going to fight, they are full of their, whatever the guns, whatever the pistols, full of energy they are. So if energy is provided, this outermost shell, this was saying, oh, I am to 2 electrons in one dabba only. There are 2 electrons in one box only. 2 electrons were just adjusting 2 electrons in one box only. And you know that. So electrons have negative charge. Negative charge, what will be there? There will be attraction or repulsion. Negative charge, in between these 2 electrons will be there repulsion or attraction. Kids, do let me know. We have to communicate fast, speedily. In between these 2 electrons, there will be repulsion or attraction. Do let me know, kids. Repulsion. So due to repulsion, once they are getting energy, this electron will say, oh, I don't want to remain over here. Once I have got energy, I would like to shift. I want to move. Zupak. It will go to that subshell, because these 2 subshells belongs to the same, you can say their shell is same, their orbit is same, they are in the same path. So same orbit, because this is also 2, both of them belong to second orbit. So too much energy is not required. Suppose if your car is moving on road and there is another road you can say on this road there is jam and second road is empty. You will shift your car to another road, but the 2 roads should not have too much energy difference. If one road is like this, another is highway, so this car cannot go to this. So what I want to say, if you are having electron in 2s electron cannot go to the third orbit, but it can go to the second. So they are belonging to the same orbit, so the electron can shift. Now once it is getting energy and it is shifting, see what will happen. What is going to happen? See, this was and this was. Now see everyone, this is, though you can say not participating, this is inert electron, not going to participate in bonding or in hybridization. You know that, kids, if I tell you that when there is war in between India and Pakistan, we teachers, we are not going to fight. We are belonging to the innermost states. Only the people who are on the border, the public or the soldiers, those who are present at the border, they are going to fight. That means these are innermost. They are not going to fight. Now, these will fight. These electrons will fight. Now, they have same spin. All they are having same spin. Now, this is having more energy. This 2p3 is having more energy than 2s. Now, kids, you must have seen one thing. When the soldiers are going to fight, they will put some black mark over here. They will put some green sticks, so that they should be like same. They all should look like same. And they start doing the, team. They are going to make team. They are going to share each and everything with each and every people, so that they can understand that what is going to happen and what is their plan. They will have teamwork. They will form group. So these are saying, I am to looking like this. I to look like this. My shape is like this. I am to like this. My shape is like this. My shape is like this, spherical. I to look spherical. I to look spherical. And now this is saying I'm 2px, I'm 2py, and I'm 2pz. What is 2px, 2py, 2pz? See kids, if I draw your physics, or you can say basic maths, so three axes, so three directions we will have. Let us suppose x, y, and z axis. So I will say this is dumbbell shaped with two lobes. One orbital is having two lobes. This is, let us suppose 2px, this is, let us suppose 2py, and this is, let us suppose 2pz. So p orbital, or we can say p subshell, is dumbbell shell. Dumbbell, you have seen dumbbell. This is spherical, this is dumbbell. One orbital with two lobes. One orbital with two lobes. One orbital with two lobes. Two lobes. Are you getting my point? One orbital with two lobes. Now kids, this is spherical and this is dumbbell shaped. Now one is spherical. Let us suppose this spherical is, orange. This is orange. And let us suppose this p is pineapple. So we are with three pineapples and one orange. We are going to take out juice from it. One orange and three pineapple. Let us suppose orange is yellow colored and pineapple is red colored. Red color. Now kids, if we are going to make juice from it, three pineapple and one orange, what do you think? One glass juice, we are going to make one glass juice. We are supposed to produce one glass juice by taking one orange and three pineapples. By taking one orange and three pineapples, what do you think? One orange and three pineapples. Now this juice will look like red or yellow. What should be the color of juice? Red, yellow, or in between red and yellow? What will be the color of this one glass juice? What will be the color of this one glass juice? Orange, red, or in between this orange and red? Red. See, this is yellow, this is red. Okay, let me take this white. Okay, now do let me know. Let us take this orange to be white. Okay, now do let me know this orange is white colored orange. Now what should be the color of this one glass juice? Now the color will be somewhat pink. That pink color will be, I think it will be pink colored. Now if somebody is going to ask how much part of this juice, pink colored juice, is having of orange, we will say it is having 1/3 or 1/4 part of S. And we will say it is having 3/4 part of this P. Am I right? Am I right or not? Am I Right or not, kids? Do let me know. Or I can say this juice is having 25% S character, and this juice is having 75% P character. Am I right or not? Am I right or not? Am I right or not, kids? Do let me know. So, this juice, I will say, better to say, this juice will be known as sp3 intermixing. One part of S and 3 part of P. One part of S and 3 part of P. Now, how the orbitals will look like? After mixing, this spherical will become a little bit thin, and this thin will become little bit spherical. Now, during hybridization, do remember, during hybridization, one lobe becomes smaller and another lobe becomes bigger. Let me tell you this thing. During hybridization, this is nomenclature, it has come. The heading is looking like isomerism. Leave it. It's not isomerism. Let me take plain slide. Okay. Do remember, during hybridization, one lobe of p orbital becomes very, very small, and most of the time it's not shown. What I'm writing, during hybridization, out of two lobes of one p orbital, this is one p orbital. These two lobes are making one p orbital, and one lobe becomes smaller. Now try to see how I'm going to draw. Just see to me. Just see on the board what I'm going to write. I will be making it like this. See, this is one, this is another one, this is bigger lobe, this is smaller lobe, this is bigger lobe, this is smaller lobe, this is bigger lobe, this is smaller lobe. Now after mixing one orange and 3 pineapples, you cannot find out from that glass. It's not easy, or it's not possible to eliminate out orange and pineapple separately. Is it possible, kids? Once if you have mixed the orange and the pineapple, is it possible to separate orange and pineapple, kids? Do let me know. Once if you have mixed the orange and pineapple, one orange and 3 pineapples, once if you have mixed, is it possible to separate and drink one orange plus 3 pineapples? Is it possible? Is it possible to separate? Do let me know in the chat section. Do let me know. Is it possible to separate? No, you cannot separate. They all will look like identical. The juice will Once if you are not seeing how many pineapples and how many oranges are mixed, you cannot find out what was the percentage. So kids, now you cannot distinguish which one is S, which one is P. Now see, this shape, I would like to say, this was pure S, this was pure S, this was your pure S. This was your pure S. Kids, this was your pure S. This was pure S. And these were pure P. See how thin, slim and trim. How thin, slim and trim. Now, I will say this is a little bit more fatty than this, and this is a little bit less spherical than this, because this is having both the three parts. Three parts means three parts of P and one part of S. So it will be known as sp3. This will be known as sp3. This will be known as sp3. This will be known as sp3. And all they are having one electron. One electron. Now, if those who are not able to understand it, those kids, still, if you are not able to understand, let me tell you, if I am having one, you can say, if I am having one Sanju, this is one Sanju, this is Sanju, Sanju Baba, Sanju, let us suppose S, and if I am having three Pintu, Pintu Baba, Pintu Baba, Pintu Baba, three Pintu Baba, one Sanju Baba, three Pintu Baba, 4% are there. Now, Pintu Baba is very lean, what to say? Thin, better to say thin. Pintu Baba is very thin, and Sanju Baba is very spherical. Sanju Baba is golu, spherical. Now, if it is possible in this world, till now it's not possible. If there is some furnace, suppose, let's imagine, let's think out of the box, that if one furnace is there, the furnace in which all four are going, let's put all these four in that furnace, and let's make, after going to this furnace, we are going to get 4 new persons. What do you think? These 4 persons will have same size and shape or different size and shape? If this is the furnace of making all the people equal, this furnace is written, let's make everyone's body same, everyone's body structure identical. So 4 people you are going to get. The 4 people will look like, I think will look like this: neither thin nor fatty, Are you able to understand? Now they all will be known as this. Its name will be sp3, 1 part of S, 3 part of P, sp3, 1 part of S, 3 part of P, sp3, 1 part of S, 3 part of P, sp3, 1 part of S and 3 part of P. 4 equivalent orbitals, 4 equivalent orbitals. Kids, just do let me know because all they are having one part of S and three part of P. All they are having one part of S. Let me tell you. If you take one sip of it, just do let me know. This one glass juice, it's made up of one orange, three pineapple, and if you just take one sip of it, you just take one sip of it. Take one sip of it. What do you think? In one sip of this juice, what you are going to get? You are going to get only pineapple, or you are going to get only orange, or you are going to get taste of one part of orange and three part of pea. Do let me know. Everyone, are you able to understand? Even if one sip you are going to take, one drop you are going to take, one drop, even one drop, you are going to get one part of that. One drop will be having one part of S, and three parts of P. Kids, do let me know in the chat section you are able to understand this much. Then I will move ahead. Everyone, do let me know in the chat section till now. If everything is clear, show me the thumbs up. Show me the thumbs up if each and everything is clear to all of you till now. Till now, if you are able to understand each and everything, I want to see thumbs up, kids. Gopi Ganesh is there. Wow. Vidhanjali is there. Esther, Shubhashri, Bhargav, Sai Ram is there. Nandu is there. Ramesh is there. Mehak is there. Killer Science, very good. Kids always used to show me the thumbs up if you are able to understand, because our communication level should be very strong. Pamela is there. Now see, hybridization is just like making group. Hybridization is just like making group. Hybridization is just like making group. To form identical orbitals of same shape and same energy. Means we can say all hybridized orbitals, all hybridized are identical in energy as well as shape. Now let me show you. This was your carbon, this was carbon, and each hybridized orbital was same energy wise as well as shape wise. Now they are ready to fight. This carbon is ready to fight. This carbon is having 4 electrons, just 4 electrons. Now hydrogen is coming towards its side. Hydrogen is coming towards its side. While having 1 electron, hydrogen is saying, oh, I'm having just 1 electron, I want to complete my duplet. Carbon is saying, oh dear hydrogen, I'm having 4 electrons and I want to complete my octet. Come on. Swagatam, welcome, Mr. Hydrogen, welcome, just come, welcome. So, see, hydrogen is like this, 1 electron. Hydrogen is spherical with 1 electron. Hydrogen is spherical with 1 electron. Hydrogen is spherical with 1 electron. So, this is known as sigma bond. What type of sigma bond it is? See, this was sp3 and this is hydrogen, head-on overlapping. head on. This is hydrogen's electron. This is carbon's electron. Head on overlapping. Head on overlapping in between sp3 and s. Head on overlapping. This is sigma bond formation. This is known as sigma bond formation. Kids, are you able to understand? It is in between sp3 and at this hybridized orbital and this hydrogen's orbital, sigma bond formation is there. So how many sigma bonds are there? How many sigma bonds? See, 1 sigma bond, 2 sigma bond, 3 sigma bond, 4 sigma bond. Now carbon is having total 8 electrons in the valence shell. Now this is the hybridization, kids. Till now this was really very basic. Now I'm going to start ahead with hydrocarbons preparation and its chemical property, and this chapter really holds a hell lot of weightage. Now everyone is ready. Is everyone ready, kids? Now see to it. It's isomerism. Let me tell you isomerism basic. See, if I talk about CH4, C2H6, C3H8, these three, they do not show isomerism. They do not form isomers. Now, if I talk about C4H10, it exists in two forms. C4H10 exists in two forms. One is CH3, CH2, CH2, CH3. You can see straight chain. It is straight chain. You can see straight chain. This is known as normal butane. And sometimes people used to say N-butane, N-butane. And second form, it can exist like this. CH3, CH, CH3. If any compound is having CH and 2-methyl over there, this is the sign of iso. On one CH, if 2-methyl are there, this is known as iso. Now, what I have to place? 1 carbon, 2 carbon, 3 carbon, only 1 carbon is left. I will say this is 4th carbon. Now, whenever you are writing iso means journal name. This is not the IUPAC name, this is journal name. Now, everyone just to let me know, I have to put iso. Why iso? Why I am putting iso? Because one CH is having 2-methyl iso, and then total number of carbons. How many carbons are there? I'm not saying total number of carbons in the parent chain. No, I'm not saying total number of carbons in the parent chain. No, total number of carbons in the compound, in the whole compound. Do let me know, everyone. Total number of carbons in the whole compound, 1, 2, 3, 4. I'm not saying in the parent chain. Total number of compound. That means I will say isobutane. Everyone, are you able to understand? Now see another compound. If I take C5H12, it will have 3 isomers. See, what are the 3 isomers? CH3, CH2, 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 CH3. Once again, this is the normal. So I will say N-pentane. 1, 2, 3, 4, 5. N-pentane. Okay. Now, if I'm supposed to make iso, what should I write for iso? CH. CH. Yes. After CH, I will write zoom. Methyl. If something is having on CH 2 methyls, CH with 2 methyls, what I'm supposed to say? On CH, if I'm having 2 methyl, I will write what? iso, I will write iso. Now, to make isopentane, total carbons must be 5. 5 carbons are required, 5 carbons. So, 1, 2, 3, what should I write? 3, 4 and 5. So, I will say this is iso, total number of carbon 1, 2, 3, 4, 5, isopentane. Now, first isomer n-pentane, second isomer isopentane, and third is, do you know the name of third compound? That is neo. So on carbon 1 methyl, second methyl, third methyl and CH2. This is the mark for neo. On one carbon 3 methyls. See kids, on one carbon 3 methyl, 1 methyl, 2 methyl, 3 methyl. Here on CH 2 methyl, 1 methyl, 2 methyl. Here on one carbon 3 methyl and CH2. This is neo. Now what is left? All carbons we have consumed, only one hydrogen is left, neopentane. This will be known as neopentane. Okay kids, I hope isomerism is clear to all of you. Now let's see the preparation of hydrocarbon. Is everyone ready for the preparation of hydrocarbon? Isomerism, so I have told you about isomerism. Let me tell you one exceptional case. See, if I want to write isohexane, how to write isohexane? Do let me know how to write isohexane. Everyone, just think in your brain. Everyone, just think in your brain how to write isohexane. I must have told you. For iso, what I am supposed to write? CH2 methyl. This is iso. This much is iso. How many carbons are left? Hexane. 1, 2, 3. So 3 carbons are left. 1, 2, 3. Everyone, are you able to understand? This is isohexane. Now, if anyone is going to write isoheptane, how to write isoheptane? What you are supposed to do? How to write isoheptane? Kids, do let me know. Just think in your brain. Just think out in your brain how to write it. Everyone, just to let me know how to write isoheptane. Just frame out a picture in your brain. Just try to make picture in your brain. See, iso. So for iso we should need CH2 methyl. This is isoheptane, means 7 minus 3, 4 carbons you are required to have. CH2, 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 CH3. Now kids, till now you must have seen one thing, that other than this, you must have seen one thing, you must have noticed one thing. Other than this was straight chain. This was also straight chain. You must have noticed this thing. So whatever you are seeing till now, all the left part is straight chain, but there is one exceptional case. Let me tell you that exceptional case. That is isooctane. This is isooctane. This is the exceptional case, and the examiner is going to ask this. Definitely examiner will ask you this thing, this exceptional case. These exceptional cases are really very, very important. See, for iso, what I am supposed to write? CH, 2 methyls. I wrote 2 methyls on CH. Now the left part was not supposed to be having any branch. It was supposed to be straight chain, but it's not following the rule. It will not follow the rule. See, CH2, see how many carbons? 1, 2, 3, 4. 4 we have consumed. See, here methyl, here methyl, here methyl. If you see from right hand side, it looking like neo, and from left hand side, it is looking like iso. From RHS, from right hand side, it's looking like neo, and from LHS side, it seems to be iso. So this is the exceptional case. It's not neo, it is just iso. Neo are only two, neopentane and neohexane. After neohexane, neo does not exist. After neohexane, neo doesn't exist. Only two neo are there. One is neopentane and one is neohexane. Now, this is isooctane. After isooctane, iso does not exist. Iso exists only up to 8 carbons. So, this is actually isooctane. It is in reality, it is isooctane. So what I am going to tell you, kids, iso exists only, I am going to tell you 2 points, most important 2 points. What are they? Isoalkane exists only up to 8 carbon, and neoalkane alkanes are only 2, that is being neopentane and neohexane. Okay, this was the brief about your hydrocarbon. Now we are going to start with the preparation of hydrocarbon. Everyone ready? How to draw neohexane? Let me tell you how to draw neohexane. See what I have told you just for neo. So I am going to tell you how to draw neohexane. One kid is asking how to draw neohexane. See kids, just for neo, what I have told you, on one carbon write down 3 methyl, 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 methyl. So we have written on one carbon 3 methyl. How many carbons I have consumed? 1, 2, 3, 4. 2 are left. So 2 are left. What should I write? CH2, CH3. This is neohexane. Everyone, is it clear? This is neohexane. Now I am going to deal with the preparation and the chemical properties of hydrocarbon. Very, very important. So everyone is ready. This was just the basic which I have told you. Now the preparation from unsaturated hydrocarbon, and this is going to be the first preparation from unsaturated hydrocarbon, like CH2 double bond CH2. This is having one pi bond. Either one you can treat to with a pi bond. Let us suppose this is sigma, then this is pi. Whenever there is pi bond, it will react with hydrogen. See, this carbon will need one hydrogen and this carbon will need one hydrogen. So it will react with hydrogen. Now kids, let me tell you, this is gas. This is also gas. And gases wants to occupy maximum space. Wow, that's really Fantastic. I can see number of students, they are full on energy. Thank you. Thank you. Ready with you, HSP Baba sir, for more tricks. Wow, killer science. And definitely Ravina is there. Everyone, you made my day and the evening. Now, both are gases and gases lie far away. You must have seen in the movie, one hero is there, one heroine is there. Hero wants to say lot of yes to the heroine, and heroine wants to say a lot to the hero, but they remain far away. Then there is the entry of the villain. There is fight in between hero and the villain. Then they come together. Now see, this gas and this gas, they remain far away. Now once the gas is getting some object, once these two gases are they getting some object, so this gas will come, ethylene will come and stay on the surface. Now from this side, hydrogen gas will come, that hydrogen gas will also stay on the surface. Now the surface is holding both of these two gases, the ethylene and hydrogen. Hydrogen will say, oh ethylene, you are unsaturated. If I'm coming to your life, I will form the bond. Your pi bond will be broken up. Now ethylene will say, what is my pi bond? Yes, your pi bond is weak bond. So hydrogen will say your pi bond is weak bond. Ethylene will say, how come you know? See how the pi bond is weak bond. Now see how the pi bond is weak bond. I will tell you the pi bond is weak bond, but before that, let me tell you this surface is of either nickel or palladium or platinum. These are the catalyst. Catalyst just participate in the reaction for short time of period, but just before the completion of that reaction, they comes back in its original shape, size and concentration. So these are D block elements, and D block elements, they have vacant orbitals. We will let you know in inorganic chemistry that D block elements, these are D block elements and they have vacant orbital, and that's why they are good catalyst. Now this hydrogen, see this pi bond is going to break and this hydrogen is going to form a bond with this. Now how it will look like? See, it will look like this, CH2, and this hydrogen has formed the bond and this hydrogen also has formed the bond. Now see kids, pi bond is breaking and two new sigma bonds are getting formed. One pi bond is breaking over here. Two new sigma bonds are getting formed. Do let me know. One pi bond is breaking. That big bond is breaking. Always energy is required to break the bond. Energy is required to break bond. And whenever the bond is formed, energy is released during bond formation. Now one big bond is getting broken up and two new bonds are getting formed. Overall energy is released or energy is required? Do let me know. The energy will get released or it will be required? Wow, Srinath, fantastic comment. I can see the comment. I think so the heroine is going to watch the hero and villain fighting. Yeah, that's really fantastic. Now do let me know. One big bond is breaking and two new sigma bonds are getting formed. In place of this, one pi bond is going to get broken up and the two new sigma bonds are getting formed. Overall energy will get released or required? Do let me know. required. No, Sonal Verma, answer is wrong. Answer is wrong. Only one pi bond is breaking. So less energy will be required to break this bond and more energy will be released. So overall, Srinath is also saying required. Overall, see kids, to break this pi bond is weak bond. Why the pi bond is weak bond? Why the pi bond is weak bond? I will let you know, but first of all, let me know. Pi bond. To break weak bond, less amount of energy is required. Let us suppose to break this bond, let us suppose to break this bond, 100 kilojoule energy is required. 100 kilojoule per mole energy is required. This is required. Now, this bond is sigma bond. Once it is formed, more energy is going to get released. Suppose 300 kilojoule per mole energy is released for this and 300 for this. So required is this much, released is that much. Suppose you have invested 100 rupees on your business and you have sold that thing for 600. You purchased for 100 rupees and you sold it for 600. You are getting some rupees or you are going to lose. Are you going to make some profit or you are going to make some loss? This much is required. That much is released. Required and released. Therefore, required we will say delta H is positive, and for released delta H is negative. Total change is final minus initial. Now say overall profit. Yes, overall profit. So overall energy will get released. So overall reaction is exothermic. Overall reaction is exothermic. Overall energy is released, and this is known as heat of hydrogenation. This is known as heat of hydrogenation, kids. This is known as heat of hydrogenation. Heat of hydrogenation. So this compound was of 2 carbons and you have got saturated compound of 2 carbons. During this reaction, unsaturated becomes saturated. In this reaction, unsaturated becomes saturated. Now see to it. If I write compound like this, CH3, CH double bond CH2, and if I write hydrogen molecule H2 molecule, and on the arrow if I written some catalyst like nickel or palladium or platinum, this is unsaturated. This is your unsaturated. This is known as propene. Propene is the IUPAC name and propylene is the journal name. Kids, do let me know what answer you are going to get. Unsaturated will become saturated. What is the name? Propane. Very good. So the compound will be like this: CH3, CH, CH2, one hydrogen we have to add at this point, and one hydrogen to with this point, and we have got saturated propane. This is being saturated compound. Now kids, do let me know, if I give you one question, if I write like this: CH3, CH double bond CH, CH3, or I give you compound like this: CH3, CH2, CH double bond CH2, and if I add hydrogen on this, both of they are going to react with hydrogen H2 in presence of nickel, H2 in presence of nickel. we are going to get the same answer or different answers? Whether we are going to get the same answer or different answer. Butane, it's simply butane. Butane is butane. So in both of these two, we are going to get the same answer, and that one is butane. Butane will be the answer. You got it. Now, only alkenes are not the unsaturated. If I take CH, triple bond CH, the name of this compound is ethyne. Ethyne is the IUPAC name, kids. And if I take its journal name is anyone. Could you let me know what's the journal name of this compound? Acetylene. Acetylene. Now see, kids, in the journal name there is ene, but it is the journal name. Don't get confused what I am saying. It is acetylene is the journal name. Now, how many pi bonds are there? 1 sigma and 2 pi bonds. Now, if you are going to add hydrogen to it, both the 2 pi bonds are getting consumed. So how many hydrogens are going to add over here? So kids, total 4 atoms of hydrogen will add up over here. 2 hydrogen atoms at this place and 2 hydrogen atoms at this place. So what you are going to get, definitely your answer will be CH. So we have added 2 hydrogen atoms at this place and 2 hydrogen atoms at this place. So overall, we have got ethane. You must have seen. So in presence of catalyst nickel, palladium or platinum, we have got this answer. Now what do you think? Chemistry Pidika Radu customer is organic chemistry Pidika Radu customer or LLA it's Romba Sulbam. Now everyone, do let me know if I give you this question. Everyone, do let me know what answer you are going to get. 3 questions I am going to give you. 1, 2, 3. One is CH, triple bond C, CH2, CH3, and it's written hydrogen in excess. And the catalyst is also mentioned. Nickel. Now second, if I'm going to use CH3, C triple bond C, CH3 and hydrogen and catalyst nickel. Now third one, I'm going to give you CH2 double bond CH, CH2, CH3. What answer you are going to get? Kids, do let me know any answer. All the 3 answers are same or they are being different? Is the answer is common for all these 3 reactions or different? Thank you. Kalakantha. Yeah, Kalakantha is there. I got it. That's really awesome that you kids have that much. You are showing that much of confidence on me. That's really, it means a lot. I'm just a hard-working man. Butane, all the case you are going to get butane. That's really awesome. Everyone's answer is absolutely correct. In all these 3, you're going to get same answer: CH3, CH2, CH2, CH3. That is being saturated compound. That is your butane. Butane is the answer. Butane. So whether we are provided with alkyne, or we are provided with alkene, they all are going to produce saturated compound. And definitely remember that I'm going to strictly follow the NCERT. If you are having NCERT of class 11th part 2, just sit with NCERT and you can see clearly I'm following each and everything of NCERT, exact NCERT. Yes, that's really, your Tamil is nice, sir. Thank you, Harini. Harini, thank you. Now, see everyone. Second preparation. And kids, this much homework I have done for you. See the headings. These headings are written by me only. How much homework I have done just to go through the sequence of NCERT, just to follow the sequence of NCERT. I have done this much of homework. See kids, from alkyl halide, two methods are there. If you see your NCERT, if you go through your NCERT, and NCERT, it's written two ways, two methods by which you can prepare alkane from alkyl halide. The first one is, now see kids how I have written. That also I am going to show you how I have written. See. Okay, later on I will let you know, but first reaction. This reaction has been asked 2 times in NEET, 2 times in AIMS, and number of times in IIT. See, alkyl halide, that is RX plus H2 in presence of zinc and HCl, Zn and HCl. We will get RH. This is the basic, or you can say common reaction. Now kids, see, RX in place of X, hydrogen has been added. The number of carbon is not getting changed. This is the most important thing. The number of carbon will remain same. This is the most important point, kids. Follow it and do remember it. The number of carbon will remain same. Number of carbon is not getting changed, and I will let you know what reaction has been asked. That was the toughest question. Now see to it. What is given in your NCERT? In your NCERT, it's given like this. In NCERT, it's given like this: CH3, CH2, Cl. Now see, RX, X should be chlorine, bromine or iodine. R can be anything, but X cannot be fluorine. Why R can't be fluorine? X can't be fluorine. X can't be fluorine. Why it cannot be fluorine? Carbon is belonging to the second period, and fluorine is also present in the second period. So the bond of carbon and fluorine is very, very strong. The bond of carbon and fluorine. So X can't be fluorine. Bond of carbon and fluorine is very, very strong. So it will not break easily. So this is like this. And if you are getting question like this, H2 in presence of zinc and HCl, what are you going to answer it? Zinc and HCl. Kids, do let me know what answer you are going to write in the examination. Everyone do let me know what answer you are going to write. What answer you are going to write. Yeah, Wurtz reaction also I am going to explain. So just remove halogen and put hydrogen. Just remove halogen and put hydrogen. You will get the answer. Just remove halogen. Remove halogen and add. Remove halogen and add hydrogen. You will get the answer. We will get the answer. Remove halogen and add hydrogen. We will get the answer. CH3. One H will go along with Cl. How the reaction will take place? See, HCl. Let me explain it. How the reaction is going to take place. See. Everyone see to it. See. Let me show it. Suppose if I am provided with CH3, CH2, Br like this, or I can write Br like this, okay. Now I am going to add hydrogen. Zinc is the catalyst. Zinc is just the catalyst. Now, what is going to happen? What is going to happen? This will take away the hydrogen and this hydrogen will be of it. Now, see what answer we are going to get. CH3, CH2, CH2, H and HBr. And the catalyst will say, oh, I haven't done anything. I haven't done anything. Now, what question has been asked in the exam, I'm going to tell you. See, I'm going to tell you what question has been asked in the exam. The question was like this: C, Cl, Cl, Cl plus hydrogen in excess, and then arrow, on arrow zinc was written over there. Now kids, do let me know what answer you are going to get. What answer will you get? This was the question which has been asked in AIMS examination, even in IIT twice in IIT it has been asked, once in AIMS. Kids, do let me know what answer you are going to get. What answer you are going to get? Benzene? No, it's not benzene. It's not benzene. See what is going to happen. How this is going to give you toluene. How the reaction is going to take place, and that's why sometimes you are going to miss it. See everyone, this was the reaction. This was the question asked. Cl, Cl, Cl. Now how the reaction will take place? See H and H, H and H, H and H. So kids, see how the reaction will take place. This Cl will take 1H, right? This Cl is having negative charge, this is having positive charge, they will go away. This once again, this Cl will take 1H, this Cl will take 1H. Now all three HCl have gone. All three HCl have been eliminated out. 3 HCls have been gone from this compound. Now these three hydrogens, or you can say hydrides, where they are going to form the bond, see, this one HCl has gone. Let me remove this. It has taken only one H has gone with this, another H will be at this carbon. So what you got? You got a compound like this carbon over here, and it has lost three chlorides, and in turn, in place of those 3 chloride, it has got hydrogen plus 3 moles of HCl and zinc as the catalyst. This is known as methyl benzene or toluene. Is everyone able to understand, kids? Do let me know. Is it clear? Of course, sir. Yeah, that's really awesome. Now, let me tell you, wow, let me add effect to this. This is really awesome. So let me add effect to this. Okay, now see, let me show you. See kids, let me see. Wow, can you see the effect? Just now I have added the effect in the Wurtz reaction. Welcome everyone, welcome to this Wurtz reaction. It's written by your HSP Baba. One effect I have added. Now let me remove that effect. Let me add another effect. So I have added another effect to this reaction. What's the name of this reaction? Kids, do let me know. What's the name of this reaction? Swagatam, suswagatam, vanakkam, welcome, Wurtz reaction. This is our most important Wurtz reaction. Everyone say Wurtz reaction. This is very, very important. Very, very important reaction. Let me give star to this reaction. Let me put a star to this reaction. Stars, number of stars to this reaction, because this reaction is very, very important. Now, you must have heard one name, Wurtz Khalifa. Wurtz Khalifa, they have stolen this name. They have stolen our Wurtz reaction name and they are talking about Wurtz Khalifa. They made one song also. Now, this is very important reaction. Let me tell you kids, this is the very important reaction. So, very important reaction. For any exam, for all the examinations, it is going to play a very important role because it holds a whole lot of weightage for any examination. Now see, think so sir got adapted to the board. Yes, Srinath, you are able to understand. Very good. That's really awesome. Now see to it. What is Wurtz reaction? In Wurtz reaction, Rx. Now what is this Rx? This R can be alkyl group, but remember this R is an alkyl group, but keep in your brain, it can be either 1 degree, or 2 degree. Can't be 3 degree or 2 degree, but can't be 3 degree, Otherwise, Wurtz reaction will not take place. Elimination will take place. That I will let you know later on. But what is 1 degree and 2 degree? 1 degree and 2 degree. Let me tell you about 1 degree. 1 degree means carbon must be bonded with only one more carbon or no other carbon So sir, tell us in detail, we are not able to understand. Okay kids, let me tell you, like CH3 Cl, this carbon is not attached with any other carbon, attached with halogen but not attached with any other carbon. CH3 CH2 Cl, this is 1 degree carbon. Which carbon we have to focus? The carbon which is attached with this halogen bonded carbon. This carbon is attached with one carbon. Let me write down one more. I hope that everyone is able to understand what is 1 degree. So whatever the chain length is there, doesn't matter, but it should be either attached to one more carbon or no other carbon. So this is the 1 degree. This is 1 degree. Now let me tell you about 2 degree. What is 2 degree? Just think about it. What should be the 2 degree? Everyone, just think about it. What should be the 2 degree? That carbon attached to 2 carbons. 2 degree is carbon attached to 2 more carbons. Which carbon? This is X delta negative. This one I am talking about. So let me give you one example of it. If I write CH3 CHCl CH3, you can see this is negative, this is positive, and this is further attached with 2 more carbons. 1 degree and 2 degree is clear. Then only we can understand Wurtz reaction. Primary, secondary, 1 degree, 2 degree. This is the substrate. Substrate means reactant. So substrate should be 1 degree or 2 degree, but can't be 3 degree. Now see, what else to see? When this Rx is treated with one more Rx, so 2 molecules of Rx required. Left hand side, right hand side. Rx and 2 moles of sodium. 2 moles of sodium. Now what is going to happen, kids? Can you think? Can you imagine what is going to happen? Zoom. Zoom, 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 zoom. Tick, 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 tick. Sodium has taken 2 halogens. Sodium is saying, hey halogen, I want to make a bond with you. I want you to be mine. Hey, don't say no, X. Come in my life. Come in my life. So sodium has taken 2x and gone away. Twice of NaX has gone. So what is left? What is left? Rara. Rara is left. RR. R. You can see symmetry is there. Can you see? There is symmetry. Rara. Symmetrical hydrocarbon. There is symmetry. You can see the plane of symmetry I can draw. You can see the symmetry is there. Can you see the symmetry is over here? You can break this compound from the middle. So plane of symmetry is there. Can you see? This symmetry is there. So we used to say symmetrical hydrocarbon. We are going to say symmetrical hydrocarbon or alkane. We have got symmetrical alkane. So this is the Wurtz reaction. But kids, R is villain. Yes. Now see, just see to it. See to it. If I'm going to take everyone, you have to answer it. Suppose an examiner has given like this, CH3Cl plus twice of Na, and the solvent is, let me tell you about the solvent also. Solvent, because you know very well, sodium is explosive towards water. As sodium is explosive towards water, sodium shows a vigorous reaction with water. So take care, as we know that sodium plus water, there is explosion. So there should not be any wet thing or water thing. Dry ether. We have to use dry ether. This is a solvent. Dry ether is the solvent which we are supposed to use. Keep it in your brain. No water can be used in this reaction. Sodium plus water explosion. That's why water can't be used. Water can't be used. Water can't be used for this reaction or during this reaction. Now, suppose the examiner has given question like this. What answer you are going to get? Do let me know in the chat section. What answer you are going to get? Ethane. Oh, already you have written. Wow, what is speed? You are going to get ethane. Ethane. C2H6. Now suppose the question examiner has not given like this. Examiner has not given the question like this. If examiner has given question like this, see to it. Everyone see to it. If examiner has given question like this, CH3 Cl plus Na and dry ether. Now what will you say? Will you write any answer or not? Will you write any answer or not? Would you give the answer or not? If the examiner has given question like this, aryl, no. In Wurtz reaction, R cannot be aryl. No, R can't be aryl. In Wurtz reaction, R cannot be aryl. Pamela Bridget, R can't be aryl. Now, everyone is saying no. Okay. Everyone do let me know one thing. If I take 1 mole of methyl chloride, if I take 1 mole of methyl chloride, how many molecules are there? Everyone do let me know. If I take just 1 mole of methyl chloride, how many molecules I am having? 6.023 into 10 raised to the power 23 molecules. When nothing is mentioned over here, do remember everyone, this is the most important thing. Let me tell you, when nothing is mentioned, nothing about equivalent is mentioned, nothing about equivalent is mentioned, then take number of molecules as per the reaction, then consider molecules required for the reaction. Suppose if you got a card from Ambani family, Ambani, you know Ambani, and nothing was written on the card that with family or only one person with one card, and you are a student, you are just a student, and you are doing MBBS from AIMS Delhi, and you are having two more friends, very close friends. You got the card from Ambani family. They have invited in one marriage. Now nothing was written on the card. Everyone's card it was written only one person with this card. But on your card nothing has been mentioned. Nothing has been mentioned. Now will you go alone or with two of your best friends? Do let me know. Nothing was written on your card that one person or n number of persons, and you are having two more close friends. You will go alone or with your friends. In everyone's else card it was written only one person with this card. Yes, when nothing is written, then you will take your friends also. So either on the card it is written with family, or it's written only one person with one card. Otherwise, if nothing is written, it's your choice. It's your choice. So when nothing is written, then you will consider this reaction to be like this. When nothing has been mentioned, you have to take, you are supposed to take this reaction to be like this. That means you are going to get ethane. Everyone, is it clear? Methane cannot be obtained by this reaction. We will never get methane. By Wurtz reaction, methane can never be prepared. Remember that. By Wurtz reaction, methane can never be prepared. Methane can't be prepared, because some of you have given the answer methane also. So do remember, by this reaction methane can't be prepared. Is it clear to all of you? By this reaction methane can't be prepared. Is it clear to all of you? One more thing let me tell you. One more important thing let me tell you. This reaction is not suitable. This reaction is not suitable for preparation of alkane with odd number of carbon. This is the very, very important point. Are you able to hear what I'm saying? This reaction, the very, very important point, many times the examiner has asked, this reaction is not suitable for preparation of alkane for preparation of alkane with odd number of carbon. So what do you think? Why odd number of carbon can't be prepared? Because the odd number carbon is looking odd or something else? Odd number of carbon, we can also say the unsymmetrical carbon. We can also call it to be unsymmetrical carbon or unsymmetrical hydrocarbon, unsymmetrical alkane. Now see, let me give you answer of this question. Suppose if somebody is trying to prepare, let's try to prepare propane, propane, propane. Let's try to prepare propane. One more thing, let me tell you. Do you know that propane is gas? Methane, ethane, propane, and up to butane. Butane, some forms are gas. Yes, LPG gas has having major constituent of what? Butane. Up to 4 carbon, they are being gases. Wow, thank you, Bhargava Sairam. Thank you. Now, this is a gas and we are going to prepare this gas. So, what do you think? What we are going to suppose we are going to take for it? Let me take one compound like methyl chloride, another compound like CH3, CH2, Cl, ethyl chloride, and I am going to react it. What do you think? What you are going to get? What are you going to get? I took this. If one molecule is written, Gaurav ji, when I will start after GOC part 2. After GOC part 2, I will start over there also. So, could you please let me know, are they one molecule or they are n number of molecules? Just do let me know. Is it possible? Is it possible to take just one molecule? Can you do let me know? Is it possible to take one molecule? If you are having one glass of water, suppose if I am having one jug of water, just a second. Suppose I'm having this much of water. Inside it water. Is it possible to take one molecule of water from this jug, from this pot, or whatever the mudden jug? If I take even a drop of water, it must be containing number of molecules. So it's not possible to take one molecule. It's very tough. So if it is written like this, that means its molecules will be n number of molecules. It's also n number of molecules. So what do you think? How many types of combinations are possible? Do let me know how many types of combinations are possible. I will like to say, definitely I would like to say that 3 types of combinations are possible. Permutation and combination, 3 types of combinations are possible. Am I right or not? three types of combinations are possible. Do let me know whatever I'm writing, am I right or not? Three types of combinations are possible. What are these three types of combinations? See, one type of combination is that this methyl chloride can react with ethyl chloride along with sodium to give you what? To give you what? To give you propane gas. To give you propane gas, CH3, CH2, CH3 gas. Another type of combination is possible, that your methyl chloride can react with methyl chloride only to give you ethane gas, This is gas, this is also gas. Now third type of combination is possible, that ethyl chloride can react with ethyl chloride to give you butane gas, This is also gas. Now kids, you know very well, during pandemic time, COVID pandemic, in our air there is nitrogen, there is oxygen. Both the gases are there. Was it possible that we can eliminate out just oxygen from the air without any machine? Was it possible? And now there is air. Oh, can I take nitrogen from the air, oxygen from the air, and I want to inhale just oxygen? Is it possible? No. Air means the mixture needs very much labor cost and very high efficiency apparatus just to separate them. Even cannot separate the blood. In blood we have white blood cells, red blood cells, platelets, blood platelets. Number of machines are required to separate them. So kids, so these gases will require too much labor cost to separate them. If the question is coming, can we prepare? Yes, it's possible to prepare, but it's not economical. Everyone is doing something just to earn money. They are doing business. They are putting factories. They are having factories just to make money, just to mint money from that business. And it is going to require too much labor cost. So it's not economical. So this type of odd number of alkane having odd number of carbon atoms, it's not economical, and that's why Wurtz reaction is not suitable for preparation of this. So this gaseous mixture is very tough to be separated. Gaseous mixture can't be separated easily, So it's not economical. This process is not economical. Economical means beneficial. It's not economical. It's not beneficial. Kids, everyone able to understand if this type of question is coming in your examination? What is cross Wurtz? There is no cross Wurtz reaction. Cross Claisen is there, cross aldol is there, cross Wurtz reaction, Pamela, Bridget. That's why we cannot say there is cross Wurtz reaction. That's why there is no name cross Wurtz reaction. Pamela, Bridget, are you able to understand? Everyone, are you able to understand? That's why no one is going to hear this name cross Wurtz reaction. So you ask this, let me tell you, on cross Wurtz reaction, just put cross. If anyone is going to ask, what is cross Wurtz reaction? So what is cross Wurtz reaction? So everyone, you have to put cross on cross-Wurtz reaction. There is no such type of cross-Wurtz reaction. So everyone, if anyone is going to ask what is cross-Wurtz reaction, this does not exist, because in cross-Wurtz reaction you are going to get number of gaseous alkanes and they can't be separated easily. That's why this name is not there. Now see, everyone see to it what I am going to tell you. Now I'm going to tell you along with this Wurtz reaction. So by preparing these many alkanes, Wurtz got publicity. Wurtz got publicity. Now everyone asked to Wurtz, is their reaction is following ionic mechanism or free radical mechanism? What type of mechanism is your Wurtz reaction following? So kids, do let me know what type of mechanism Wurtz reaction follows. Mechanism followed by Wurtz reaction. Is there anyone? Mechanism followed by Wurtz reaction. Mechanism followed by Wurtz reaction. So it follows two type of mechanism. Killer signs, Bhargava Sairam. Just this is the very important point. It follows, this reaction follows two type of mechanism. What are these two type of mechanisms? That means it is going to follow ionic mechanism. Along with that, it is going to follow free radical mechanism also. This is a very important question. It will follow both type of mechanism, kids. This is the most important question of your egg. At that time, AIMS was taking separate exam, even IIT and everything. Now see what I am going to tell you, how it is going to follow both type of mechanism. See, one side, let me write down ionic mechanism. Another side, I am going to write free radical mechanism. And kids, you must be going to understand why the two type of mechanism is required. Ionic mechanism. See, ionic mechanism. This is, let us suppose the reaction given is, the reaction has taken like CH3, CH2, Cl, Na, dry ether. This is your reaction. Okay. Now, this ethyl chloride, we know that this bond is polar bond, polarized bond. Why this bond is polarized? Polar bond. Why I am saying this is polar bond? Because chlorine is more electronegative than carbon. So chlorine is withdrawing electron towards itself side, and the electron of carbon has been shifted more towards chlorine side. So carbon and chlorine, there is cold war. In between carbon and chlorine, there is cold war. Carbon is saying, hey chlorine, you have taken away my electron. Chlorine is saying, hey, I'm more electronegative than you. I will snatch your electron. I will give you one tight slap on your face and I'm going to take your electron. I'm just waiting for somebody. I'm minus I and you are plus I. I'm electron withdrawing group or atom. You are being electron donating group. So one day chlorine has snatched electron of carbon. One day what happened? Chlorine did the thing for what carbon was not prepared. Chlorine has snatched electron of carbon. Now chlorine is like this. Carbon is started crying, oh chlorine, you have taken away my electron. Now I'm having just 6 electrons in the outermost shell and you are having 8 electrons. Now, although chlorine has snatched one electron, but while snatching this electron, chlorine has developed negative charge. Charge is like disease. The atom, if it is having charge, that means it is not stable. While snatching electron, although it has completed its octet, but chlorine is not happy because it is charged. And carbon is lost. Carbon has lost electron. It's so really unhappy because it is neither having electron money nor having stability. Both the charge and electron deficiency started crying, "Ooh, mummy, mummy, my electron has snatched by chlorine." Now, in front of this carbocation, sodium molecule was going. Sodium was saying, "Hey, I'm having one extra electron. Hey, I'm having one extra electron. Just take one electron from me, one electron from me." So, sodium has donated one electron. Sodium has donated one electron, as sodium is really electron donor. Now, by accepting this electron, what is going to happen? Now, number of sodium molecules are there. Two sodium, two electron. By accepting these two electrons, by accepting one electron, carbon's plus charge gone, and by accepting extra electron, this carbon has developed negative charge. This carbon has developed negative charge, and now this carbon is looking like this: CH3, CH2, negative. Now it is having 8 electrons. Then also it is unhappy. Earlier carbon was having just 6 electrons in the outermost shell. It was unhappy because it was having positive charge. Now it is having 8 electrons. Then also it is unhappy. Why? Now the electron is completed, octet got completed. What? Then also it is unhappy because everyone knows from GOC part 1. In GOC part 1, I have told you stability is inversely proportional to charge. Those who have not seen GOC part 1, let me tell you, stability is inversely proportional to charge, whether that is plus charge or that is being negative charge. Stability is inversely proportional to charge. This thing, so we should know, otherwise we won't be able to do anything, right? So, charge is not a good thing. Charge is not a good thing. Now, what is going to happen? This carbocation will call his brother. "Hey brother, come here." What happened, bhaiya? What happened? "Hey brother, come here." Sodium, two sodiums are there. One, it has lost one chloride. So how many chlorides are just moving in the solution? One chloride is moving, one more chloride is moving. So two sodium will form bond with this, and solid crystal lattice structure they will form, twice of NaCl. Their life to happy. Their life is really prosperity they have gained. Their prosperity is there. Now this will say, just take away this chloride. This chloride will go away from this, and this is going to develop positive charge. That means it will look like this: CH3, CH2 positive, and this chloride, one chloride, this one, and one chloride is gone from here. Now this and this, see, they will come together. CH3, CH2 negative, and CH3, CH2 positive. CH3, CH2 positive. Now it is having 8 electrons and negative charge. It is having just 6 electron and positive charge. What is going to happen? +1 and -1. You must have studied this maths in KG class or first or second class. +1 -1. +1 -1, what is going to form? One bond. Bond is known as butane. This is known as butane. CH3, CH2, CH2, CH3. Till now this was ionic mechanism. So let me rub this line because it was ionic mechanism only. Ionic only. Now see, what is the need of free radical mechanism? But before going towards free radical mechanism, do let me know everyone is able to understand this thing, whatever I have told you. Is everyone able to understand it? Till now, whatever I have told you, are you able to get it? Just show me the thumbs up. Okay, let me show you the brief of it in short. Let me tell you in short, brief of it. Do let me know how many of you are able to understand, how many of you are not able to understand, then I will tell you in short. See, what has happened over here, two molecules of CH3, CH2, Cl, no, let me take one only, otherwise you won't be able to understand. It was like this. This chloride has taken its electron. Once the chloride has taken its electron, how it will look like? It will look like this: CH3, CH2 positive. This chloride like this, it's like this. Now one more molecule of ethyl chloride is there, CH3, CH2, Cl. Same is happened over here also. It will look like this: CH3, CH2 positive, and chloride in the solution. Now kids, in the same solution you have added sodium also, twice of sodium. Sodium is going to donate electron. It will look like this: twice of Na positive plus electron. Now what do you think? Electron is like money. What do you think, what can happen? Two possibilities are there. If you just try to understand, two possibilities are there. See, what are the two possibilities? First, so let me tell you, these two sodiums will capture this chloride. And they will form NaCl, right? This sodium can combine with this, so they will cancel out. They will get cancelled out, and they will form what? Twice of NaCl. They have formed twice of NaCl. Now they are no more in the solution. Now this carbocation is there, two electrons are there. Carbocation means how many electrons? Just 6 electrons in the outermost shell, valence shell, 6 electrons. Now how to know that they are having 6 electrons only? Carbocation always means, this I have told you in GOC part 1, this is carbocation, 3 bond. One bond is formed due to 2 electrons. One bond is formed due to 2 electrons. So 3 bonds, that means 6 electrons, right? 6 electrons carbocation. Now kids, now two possibilities. What are these two possibilities? One possibility is that these 2 electrons can be captured by this carbocation only. Then this will become carbanion, and carbocation will form a bond. 2 electrons can be gained by one single molecule. This is possible. Or what is possible? That 1 electron can be gained by this molecule and 1 electron can be gained by that molecule. Then they are going to form free radical. You can see very clearly that 2 persons are there. Just need of money. This needs 2 lakh, this needs 2 lakh. 2 lakh rupees are there. Either to possible that both the 2 lakh can be captured by this person, or it may be possible that 1 lakh can be captured by this person and 1 lakh can be captured by that person. Two possibilities are there. If 2 electrons are captured by one molecule only, then they will still remain ion only. Then we will say it is following ionic mechanism. That means in this case, this molecule is going to change into this molecule CH3, CH2, negative 8 electrons. Now we are just having this one and this one. Electrons have gone, electrons gone. Now only we are having this molecule in the solution and this molecule in the solution. This has also gone. Now this is rich, this is beggar, this is carbon, and that is carbocation. Carbon-carbon new bond formation will take place. Everyone is able to understand? Thank you. Thank you, Srinath. Thank you. Now carbon-carbon new bond will form. So we will get CH3, CH2 positive, and CH2 negative, CH3, carbon-carbon new bond formation. Brother, carbon-carbon new bond formation. Carbon-carbon new bond formation. right? Now, let's see the free radical mechanism of it. Everyone is ready? Just to see the free radical mechanism of it. Is everyone ready, kids? Free radical mechanism of Wurtz reaction. Free radical mechanism. Everyone is able to understand or not? Is everyone able to understand? If yes, always try to share it. People, they don't know. They don't know who am I, who is HSP Baba. Thank you, Killer Science, thank you. So always try to show your factions, show your thumbs up. Always, if you're liking my lectures, otherwise I get demotivated. That kids, where are the kids? Now see, kids, free radical mechanism. Now, CH3, CH2, Cl, chloride is saying, oh, I will go, I will go, I will go, I will take your electron, I will take your electron, you will be loser, loser. So chloride has gone. Now it will look like this: CH3, CH2, free radicals, 7 electrons in the outermost shell. Now one more molecule will be like this: CH3, CH2, Cl. Chloride said, I will take your electron by heterolytic cleavage, and you will be like this: CH3, not free radical, it's positive charge, sorry, positive charge over here, because chloride has taken electron, sorry, chloride has taken electron, so it will be positive charge, positive charge, positive charge. Now two chlorides are saying, oh, I am the negative charge. Now they will come when sodium has come to their city, twice of sodium. Sodium is saying, oh, just I want to donate electron, I'm electron donor, I'm electron donor. Now see, these are negative charge, these are negative charge, they are not interested in this. Sodium has become sodium plus, so sodium will form bond with these two chlorides. Hey, I'm to yours, twice of NaCl. Now one electron will be taken by this and one electron will be taken by this. They are right now having 6 electrons, 6 electron. By gaining one electron, they will become free radical. Wow, that's really fantastic. Yeah, definitely I will ask the team just to make playlist. Okay. Now see, each one has taken one electron. Now how they got turned? They are now looking like this: CH3, CH2, free radical, 7 electrons in the outermost shell. This is also looking like CH3, CH2, free radical, 7 electrons. Now they also gone from here. They also gone from here. Now 7 electrons, they will say, oh, we both are having 7 electron. Let's form a bond. Let's form a bond. So they will come together and they will form new bond, and they will be known as CH3, CH2, CH2, CH3. Now you will ask, sir, this has also formed butane and that was also forming butane. What's the difference? What's the difference in between two mechanisms? Kids, on this mechanism, scientists started to do research because during this reaction, one compound has been formed, and that's why they have gone for this reaction. That compound's name was ethylene. By ionic mechanism, you cannot prepare ethylene, but during this combination, this is the best combination, this is the major reaction, but in major amount, this we are getting, along with this major amount, we are going to get one minor product also during this reaction. During this Wurtz reaction, ethylene was also formed. During this reaction, During this reaction, ethylene gas was also produced. Ethylene gas in minor amount, in minor amount was also produced, which can be explained only by, ionic free radical mechanism, which can be explained by, free radical mechanism only. Now see, this is CH2 free radical. This is also CH2 CH3 free radical, right? Can you see everyone? Should I write once again? Let me show you once again. See, either I can write like this: CH2H, CH2 free radical, CH2 free radical, CH3. Both ways I can write. Now, what can happen? See, just see to it. It will happen in traces only. There will be homolytic cleavage. This electron and this electron, there can be homolytic cleavage, homolysis. See, homolysis. This hydrogen will take one electron of it. One electron of this hydrogen, it can take its own electron, and by taking this electron, it can go to this carbon. You can see. Just see to it, then I will explain. This hydrogen is taking electron of its own and going to another carbon. Are you getting this? Ding, 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 ding. I am to going to this carbon. Now, how it will look like? By losing electron, it will look like this. CH2. And by gaining hydrogen along with electron, it will look like, it's so life completed, happy life. So it got changed to this, and this one turned into this one. Are you getting it? Its to octet got completed. Happy life. Now, just to manage its life, what it is going to do, it is having right now 7 electron. This is 7 electron. They will come together and they will form a bond. Ethylene gas. This gas is used for ripening of fruits. So this is formed in minor. This is formed as minor product. And ionic mechanism does not explain this product formation. Kids, everyone is able to understand? Do let me know in the chat section. Show me the thumbs up if you are able to understand it. Everyone, show me the thumbs up if you are able to understand. Kids, show me the thumbs up. Everyone. Yes. Now see. Now, fantastic question on Wurtz reaction. Let me show you some questions. Really awesome questions on Wurtz reaction. Now see. If examiner is going to ask this question. See, this question can be asked in two ways. Once, so nothing written over there. Nothing written over here. Once nothing is written on the substrate side, in just below the substrate side, you are free to take anything. Now see, n number of molecules, this means n molecules. And if n molecules are there, what do you think? Which bond is stronger? Carbon, this is carbon, carbon, this is carbon. Carbon belongs to the second period. Carbon belongs to second period, and fluorine, chlorine, bromine. You can see 2, 3, 4. Which bond is more stable? Do you let me know? Which bond is more stable? Carbon to chlorine bond is more stronger. Am I right? Am I right, kids? Carbon to chlorine bond is more stronger. So this bond is weaker bond. This bond is weaker bond. Why this bond is weaker, kids? Weaker bond. This is a weaker bond. Overlapping is not good. So this will break. This is going to break, kids. Let me tell you, this bond is a weaker bond because overlapping is in between 2p and 4p. And this overlapping is between 2p and 3p. And if fluorine is there, bond is not going to break. So this is your weaker bond. Weaker bond. Now, how to proceed this reaction? How to proceed this reaction? See to it. How this reaction should be proceeded. So, you have to bring this bond. Bromine, chlorine will remain over here. Stronger bond will not going to break up. And twice of sodium, it is going to form bond like this. NaBr will get eliminated out and your product will be like this. This new bond formation has taken place. This new bond formation has taken place. Chlorine will remain over here and this chlorine will remain over here, and twice of NaBr will get eliminated out. Are you able to understand? Everyone is able to understand. But the question can also come like this. Once it has been asked in IIT, let me tell you, the question can also be asked like this. If they are going to give you compound like this, in the question it has given like Cl, Br, one equivalent only, one equivalent. If specifically it is written, mentioned one equivalent only, that means you have to take just one molecule and you are supposed to complete the reaction. Now what you will do, how to carry out this question, how to proceed in this question? Is there anyone? Na dry ether. Now you have to proceed it like this. There will be the cleavage of bond. There will be the cleavage of bond like this. The free radical mechanism bond will break from here. Homolysis, homolytic cleavage, homolysis. So one electron will be taken by this chlorine, one electron should be taken by this bromine, and they will be like this. Now what do you think? What is going to happen? What is going to happen? NaCl, NaBr will eliminate out. NaCl, NaBr will eliminate out. Now they will start forming a bond. They will start. Okay, Srinath, now you are able to understand. Very good. Now not cyclobutene, see, they are going to form a new bond. They will start forming a new bond like this. In between them, a new bonding will start forming like this. and this I can say is the transition position, and the bond will be like this. See how the bond will look like. It's everyone see to it. The compound will be like this. This is the new bond, and this is known as, yes, bicyclo. Bicyclo compound has been formed. It's not cyclobutene, it is bicyclo. This is known as bicyclo. Bicyclo. Now, kids, I can't understand as the time proceeds. I will give you a break. I will give you a break. But as the time proceeds, kids, they start moving. Did my teacher, sir, let me see to it. Sir, my class teacher saw me using multiple materials and told me not to get confused using them. He told no. Kids, the paper comes from 70 to 75% from NCERT and rest from out of NCERT. I would not like to say NCERT out of NCERT. NCERT writes really, NCERT is very smart. NCERT used to write in between the lines, and if you're not able to understand each and everything, you're not going to get even the selection. I'm not saying the rank, because only from NCERT, by going through just through NCERT, you can't get the best marks. Srinath, so always focus on the things. I'm not saying just go beyond the syllabus, but yes, everything, each and everything is not given in the NCERT. Just NCERT is touching the things. NCERT is not going to write each and everything. So these things are required. I don't know why school teachers, they used to say like this, or they are saying like this. Not all the school teachers are doing the same job. Some school teachers are really very good. They give, they used to give, and they are giving the correct information, what to use, what not to use. Yes, just follow what I am giving you, because I will give each and everything required for first rank, up to first rank. I will not skip, I will not I'm not going to leave even a single thing, and I'm not going to teach you out of syllabus. I will teach up to first rank, nothing out of syllabus, and nothing I'm going to leave. Now kids, this is the answer. Now kids, if question is coming like this, once this question has been asked about the Wurtz reaction, this question has been asked. Now, it's simple fundamental thing. It's not tough. See kids, what is going to happen? This is going to form a bond with this. That's really simple. So what answer you are going to get? Your answer will be like this. These are the regular bonds, and new bond has been formed, which is being the new bond. This new bond has been formed. So answer is cubane. Cubane is your answer. Cubane is your answer. And twice of NaCl has been eliminated out. This is the thing, and this is the way. Srinath is saying, I'm just following you. Yes, Srinath. Oh, from Vedantu till Unacademy, you are the staff from I follow for my dream. And now, yeah, definitely, Srinath. Always, everyone, Mark my words, whatever I am going to tell you on this board, from those examples only directly you are going to get questions. Nothing out of syllabus and nothing I am going to leave. I'm not going to leave even single word. From the bottom of my heart, I'm telling you, whether I'm going to teach you on the platform Unacademy Plus or over here, I always mean same. You are my student. Just, I cannot see you people. You must be thinking like that. But this camera, whatever I can see in this camera, I'm just think in this camera, God is present over there in the form of student, in the form of all the students, those who are watching from all over the entire country or outside the country. God, I can see the God in the form of all these students. Their calculus means integration, integrated form of all the students, and integrated form of all the students at one place. I can see this integrated place at a single point. You are like God, and in front of God, how to go out of the path. Whatever I'm going to tell you, I will tell you each and everything what is required for your rank. Pamela, just see that lecture. I will let you know that isomers lecture. I will take isomers lecture and then I will let you know. Now, no, I am a simple teacher. I am a simple teacher, but see kids, this is the answer. Wurtz reaction is complete. Now at 8:30, I will give you a break. I will give you a break at 8:30, right? So still 12, 17 minutes are left. So now see, everyone see to it. Now, if examiner is going to give you a question like this, now along with Wurtz, if somebody is saying Wurtz-Fittig, Wurtz-Fittig, now see, it's not written properly, so let me write down like this only, Wurtz-Fittig reaction. Now first let me tell you Fittig only. So let me tell you Fittig, then I will let you know. Along with Wurtz, there was scientist known as Fittig. Whatever Wurtz has explained for aliphatic, Fittig has explained with aryl. So aryl, ARX, so you can say like this, or I can write X over here, and X is equal to either chlorine, bromine or iodine, 2 moles of it, twice of Na dry ether, what you are going to get? Biphenyl. You will get answer as biphenyl. Biphenyl plus twice of NaX. Biphenyl is the answer. Everyone, is it clear? This was the Fittig scientist. Fittig has taken aryl halide. Fittig has taken aryl halide. What Fittig has taken? Fittig took aryl halide. Fittig took aryl halide. Now, both combined together and they form a group. Now that group's name is known as Wurtz-Fittig reaction. Now see, Wurtz-Fittig reaction. That group is known as Wurtz-Fittig reaction. Now see, Wurtz-Fittig reaction. Wurtz-Fittig reaction. Wurtz-Fittig reaction. What they did, one aryl halide, one alkyl halide, they combine together in presence of sodium ether. Now see, this is aryl halide, that is being alkyl halide. So one kid was asking cross Wurtz reaction. It's not cross Wurtz reaction, it's not cross-Fittig reaction, it is Wurtz-Fittig reaction. So you are going to get compound like this. So once they have asked this question, in the question they have given chlorobenzene, they have given methyl chloride, and they proceeded. What should be the answer? Do let me know what should be the answer. I want to see your answer, kids. Yes, King's Life. That is absolutely true, Srinath. Yes. Toluene. Yes, toluene is the answer. And this you got by Wurtz-Fittig reaction. This is the answer. This is the answer. And twice of NaCl will get eliminated out. So everyone is able to understand Wurtz reaction, Fittig reaction, Wurtz-Fittig reaction. One more reaction is there. That is known as Frank-Land reaction. And see, Frank-Land reaction. Let me tell you about the Frank-Land reaction. What is there in the Frank-Land reaction? See to it. Frank-Land reaction. Now these reactions are not given in your NCERT. Frank-Land reaction. Frank-Land reaction is not given in NCERT. It's not given in NCERT. Frank-Land reaction. Let me write down once again. Frank-Land. Frank-Land. Which land? Frank-Land reaction. This is not given in NCERT, but number of times they have asked. What to do? 2 moles of RX, alkyl halide. Now, in place of sodium, you have to take zinc. This is the only difference. In place of sodium, you have to take zinc. Zinc has got the ability to donate 2 electrons. 2 electrons. Zinc will donate 2 electrons. Now, only zinc. No dry ether is, because zinc is not going to do explosive reaction with water. Zinc will not do explosion with water. No need of dry ether. Now what you are going to get? Rara, RR and ZnX2. ZnX2. Now one more reaction is there. That reaction's name is Ullmann reaction. Ullmann. This is also not given in NCERT. These 2 reactions are not given in NCERT. These 2 reactions are not given in NCERT. What Ullmann has shown? Ullmann said, just take aryl iodide 2 moles, and now use copper. Copper though not reactive with water. Copper and heat. Now what you are going to get? You will get biphenyl plus CuI2. Now these 2 reactions are not given in NCERT, but yes, examiner can definitely ask these 2 reactions in the match the following or any type of question like that. So these 2 reactions are very, very important. Now it's 8:30. Both the reactions are important. These 2 reactions are important. Now it's a break time. So will you come after the break with the full on energy? Just do the promise, then only I am going to give you the break. MSc gold medalist, then now is father of IIT NEET chemistry lecture, killer science. Thank you, thank you. Everyone, just do the promise. Will you come with the full on energy? Let me tell you. It's 8:30 to 850 will be okay. So we will meet at 850 with full on energy. Full Josh. Okay, kids. Is it okay? Okay. Okay. All the best. Once again, welcome back to each and everyone. Hey, how's the Josh? Everyone, Namaskaram. Welcome once again, your HSP Baba. So, kids, what I can see, yes, in the chat section, fire is going on. And if I'm perfectly audible and visible to all of you, once again, I want to see that, yes, kids, your energy level, wow, that's really awesome. But remember that one thing, that I'm just going to complete the preparation. 3 more methods are there still left. One is being Kolbe Electrolysis, one is being soda-lime reaction, and third is being preparation from the Grignard Reagent. This time, number of questions has been asked in IIT from Grignard Reagent. Now, after preparation, I will let you know the chemical properties of alkane, and then the chapter will get completed. I'm not going to leave even a single thing. Even if you see your NCERT, you will be able to understand each and everything. And if you just see any questions of PYQ, previous year question, whether it is of NEET or previous year AIMS or of IIT, you can do all the questions. It's just common. Chemistry is common for NEET and IIT. So I'm damn sure, definitely, whenever you're going to deal with any PYQ, you are going to solve each and every question. Wow, Srinath Argato Gozamis Sensei. Oh, which language is this? I'm unable to understand this language. Qualitative analysis, I will let you know later on, kids. Qualitative analysis is very, very important. That plays important role when you go through inorganic chemistry. That I can say it holds a whole lot of weightage for inorganic chemistry for all those type of questions. But right now, we have to deal with hydrocarbons. So, kids, are you with full of energy? Full on energy, full of Josh. How's the Josh? So let's start the preparation. Everyone is ready? Everyone is ready? Ready. Okay, now see. So let's move ahead. Now, this is also I have written only. See, preparation from carboxylic acids. If you see your NCERT, in the NCERT, it's properly written that from carboxylic acid. The 2 types of ways are there. One is being decarboxylation and one is being Kolbe's electrolytic method. This decarboxylation is also known as soda-lime reaction. This is also known as, kids, what? This is also known as, what I'm saying? This is also known as soda-lime reaction. This is also known as soda-lime reaction. Soda-lime reaction. And the third name for it is lab method preparation of alkane. So this reaction is very, very important, and that's it's also very, very important. Both of these 2 reactions are going to play very, very important role for your selection. So whenever I talk about important reactions, I will put very, very important. Once if I say the reaction is very, very important, that means it is about to come. This will definitely come in your examination. Very, very important. So 2 very, very, very important means really very important reaction. Okay. So don't worry, Abhishek, me and Wasim sir, both will take care of inorganic chemistry. So don't worry about it. We are equally good in inorganic chemistry, right? So better to say full chemistry, both of us are equally good. And that's why this is the best channel. You are studying over here with best 2 chemistry teachers, physics teacher, biology teacher, right? The best channel, that's right. This is soda lime reaction. Now let's start with decarboxylation. Now decarboxylation, simply if I say, mostly you will see it like this: R C double bond O O N A. This is sodium salt of carboxylic acid. Better to say sodium salt of carboxylic acid. Sodium salt of carboxylic acid. This is the basic. Now, mostly you will see in your examination, this is reacted with NaOH, and along with NaOH, they could give you calcium oxide. This calcium oxide acts as the catalyst. Why the calcium oxide is always given along with sodium hydroxide? The reason for that is sodium hydroxide is deliquescent in nature, or efflorescent. Yes, hygroscopic. What do you say? Efflorescent, deliquescent, hygroscopic. These are confusing words, but let me tell you, this is deliquescent. Why it is deliquescent? Actually, NaOH is not deliquescent. It is deliquescent because of impurity, because of impurity of what? Impurity of MgCl2 along with NaOH. And this is hygroscopic in nature, hygroscopic. Now, you must be thinking, what is the main difference between deliquescent and hygroscopic? This thing I will let you know later on, but right now let me tell you one thing clearly. It absorbs moisture from the atmosphere. That also absorbs moisture from the atmosphere. Both of them, they absorbs moisture from the atmosphere, but it becomes wet and it does not become wet. One becomes wet, one doesn't become wet. So this is hygroscopic, even though it is absorbing moisture from the atmosphere but not becoming wet, but this becomes wet. Anyways, leave it. Just where to focus, just think over it. You have to remove this Na along with that, 2 moles of that, and that is going to form Na2CO3, and this H will come over here, and the answer will be yes. So this carbon dioxide will also get eliminated out. This CO2 will also get eliminated out. This will also get eliminated out. So no need to take 2 moles, even you can take 1 mole only, 1 mole only, and you just remove like this. See, this R is having negative charge. It has withdrawn electron. This is having delta positive. This is delta negative, and this delta positive. Just put this H plus on this R. R negative and H plus, what are you going to get? R negative. P by Q of this question, I will let you know. Along with all these things, I will tell you the P by Q. See, once I am telling you the concept, and just after the concept, I am giving the questions and I will ask the answer, right? Once telling you all these things, I will tell you the concept, and then I will explain that concept, and then I will give questions for you people, right? Okay. Now see, this R negative and that H positive, they will combine together. Who is going to get combined? See, this R negative, zoom, and this H plus, they will combine together. And what they are going to form? RH. So the answer is RH plus Na2CO3. Na2CO3. This is just the catalyst, you can say, additional material. Now, after telling you this much, if I am going to ask question based on this, see to it, everyone see to it. If you are asking for MCQ, see what question I can ask, what question examiner can ask. CH3 COONA, either to he will give you structure of it, or the name can be given sodium acetate. The name is sodium acetate. Sodium acetate. Now, he can give you NaOH. NaOH is known as caustic soda. Caustic soda. And this is quicklime. This is quicklime. So what's the answer? I have not given you the options. Even though I have not given you the options, but I am asking the answer. What should be the answer? Even though options are not provided. Now see, just take it out and add one proton to this. CH3 negative, one proton. Just add one proton to this. What answer you are going to get? CH3H. Methane is the answer. Methane is your answer. Now see kids. Methane can't be prepared by which reaction? By Wurtz reaction, methane can't be prepared, but methane can be prepared by, yes, soda-lime reaction. By soda-lime reaction, methane can be prepared. Now, if by chance, examiner is going to give you this question. Examiner has given you this question. See, if examiner has given you this question, sodium benzoate, COONA, sodium benzoate. If sodium benzoate is given by the examiner, so what will you write? What's your answer, kids? NaOH, caustic soda, quicklime, CaO. What answer you are going to get? I'm not going to give you the options. Even without options, if you are going to tell me the answer, that is the real thing. Benzene. That's really fantastic. Your answer will be benzene. Benzene is the answer, plus sodium carbonate, Na2CO3. Now see, this was the easiest one. This was the easiest one. Let me tell you kids, this was the easiest one. But up now, to suppose examiner has not started with the sodium salt of these acids. Suppose he has started giving question with this thing. Just see to it. If examiner has started question from here, R C double bond O OH, and he has started with carboxylic acid. He has started with carboxylic acid and NaOH, excess, and quicklime, CaO. Now, kids, you will start thinking, you might start thinking that it's not the soda-lime reaction because this is only the carboxylic acid is given. Here sodium salt is missing. Now see what the answer you are going to get and just try to find out. This is acid. This is your base. What do you think? You have been studying this thing from your childhood, from class 9th. When acid and base reacts, what is going to happen? Acid-base neutralization will take place. Acid-base neutralization will take place. So this will convert into RCOONA, Rexona. Once it has converted into RCONA, once again it is going to react with NaOH and calcium oxide. So definitely, once again, your answer is same, that is RH plus Na2CO3. Are you getting my point? Are you getting my point? So whether the question is given like this or the question is given like this, whatever the question is given, suppose they have given you a question like this. This is phthalic acid. What is the name? Its name is phthalic acid. In polymerization, you will study phthalic acid. This is your phthalic acid. And whether they can give you triphthalic acid. Its name is triphthalic acid. They are isomers. This time IIT has asked triphthalic acid. Now, if they are going to give you a question like this, phthalic acid and triphthalic acid, they have been treated with NaOH and nothing is written over there. You can use whatever the amount you want, NaOH, calcium oxide. What answer you are going to get in both the two questions? This is A, this is B. Although I have not given the options, but then also I am expecting the correct answer from you people. One is being phthalic acid, one is being triphthalic acid. P is silent over here. P is silent. So what answer you are going to give? These are the questions, previous year questions, multiple choice questions. If you are going to give the correct answer, do let me know. Killer Science has given benzene. So kids, definitely this answer is absolutely correct. In both the two cases, you are going to get benzene as the correct answer. Benzene will be your correct answer. Are you able to understand, everyone? Now, these are the easiest question. Everyone can do this question. But if tough questions, they are going to ask how the question can be asked. Now, see, for rank deciding, if we talk about rank deciding questions, how they can ask the rank deciding questions. See to it. Everyone see to it. Rank deciding questions. So for doing rank deciding questions, we should know mechanism. Rank deciding questions. So rank deciding question means we are provided with R, C, double bond O, OH. Just to remember how the reaction is going to proceed. During this reaction, carbanion is the intermediate. This carbanion means carbon will hold electron of its own and carbons. So carbanion will be the intermediate. Just remember it, that carbanion is the intermediate. Carbanion is the intermediate. Once the carbanion is the intermediate, so always remember, rate of reaction is always directly proportional to intermediate. More is the stability of intermediate, more easily the intermediate will get formed and more will be the rate of reaction. So I would like to say that rate of decarboxylation reaction is directly proportional to stability of carbanion. Stability of carbanion. Is this point clear to all of you? More is the stability of carbanion, more easily it will get formed and more will be the rate of reaction. What I am telling you, more is the stability of carbanion. Let me tell you, more is the stability of carbanion, more is the stability of carbanion, more easily it will get formed, more easily it will get formed. More will be the rate of reaction. Now, these three are the golden points. If you remember these 3 points, you can solve any question. You can solve any question. Let me tell you how the question they have asked. See, the question has been asked like this. Arrange the following. Arrange the following in decreasing order of, the sign is for decreasing order of rate of decarboxylation, rate of decarboxylation. Rate of decarboxylation. What are the options given? See, option A was given like this: CH3, 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 COOH. Just to solve this question, you need one thing: GOC part 1, carbanion stability order. If you don't know the stability of carbanion, then you won't be able to do this question. But here I will let you know, once you try it, if you're not able to solve it, I will help. So I'm not going to give you the options. I think it's very clear. Just try to find out which out of these four, A, B, C, D, is going to decarboxylate easily. King's Life, do let me know. Yes, everyone. Now see to it. This is going to be 3-degree carbanion, because 3 carbons are attached to this carbon. 1, 2, 3. 3-degree carbanion. This is going to form 2-degree carbanion, because this carbon is attached with 2 carbons. 2-degree carbanion. This is going to form 1-degree carbanion, and this is also going to form 1-degree carbanion. So you know that methyl carbanion is more stable. The stability of carbanion, this one is more stable, methyl carbanion. So the answer is maximum rate of decarboxylation will be of D, then C, then B, then A. This will be the order for decarboxylation reaction. If you are agreed, then do let me know. This will be the rate of decarboxylation reaction. Everyone agreed? Do let me know. Thumbs up if everyone, you are getting this answer. D is more stable. Yes, because the carbanion stability order is methyl carbanion is more stable. After methyl ion, 1 degree, then 2 degree, then 3 degree. This is the stability order for carbanion. Carbanion stability order. This I have told you in GOC part 1. This is carbanion stability order. Kids, this question is clear to all of you. Now, let me give you another question. Are you ready? Let me give you another question. See to it. Everyone see to it. Once again, arrange in decreasing order of decarboxylation. Arrange in decreasing order of decarboxylation. Decreasing order of decarboxylation. Now, I will just give you 2 options or 4 options. How many options you want? Let me give you 4 options. CH triple bond C, CH2, COOH. Second option, CH2 double bond CH, CH2, COOH. Third option, CH3, CH2, COOH. D option, CH3, 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 CH2, COOH. Now see to it and try to understand what should be the answer. Just take it as your exam, final exam, NEET exam, and try to answer it, everyone. Yes, everyone. Everyone, what's your answer? CBAD. CBAD. Let's see. What's the correct answer? C. CBDA. Jyoti Kumar. Everyone see to it. Let me tell you first of all that this is sp hybridized carbon ion, and sp hybridized carbon ion's electronegativity is 3.25. It is even more electronegative than nitrogen. This is sp2 hybridized. This carbon's electronegativity is 2.75. This is 2.5. This is 2.5. Now how to do it? How to do it? A, B, C, D. Yes. Bedha Janani. Bidhan Janani. Right? Answer is absolutely correct. This carbon ion is going to be more stable because this is electron withdrawing group. Electron withdrawing group. This then electron withdrawing group little bit, but this is the electron donating group. This is the electron donating group, and there are 3 electron donating groups because this is, so this carbon ion is least stable. Carbon ion is going to be least stable. Carbon ion will be least stable, will be least stable, right? And its carbon ion is going to be more stable. So definitely your answer is going to be A, then B, then C, then D. This is your answer. I hope everyone is agreed to this. Rate of decarboxylation, this is your answer. Is everyone agreed? If yes, show me the thumbs up that you are able to understand. That you are able to understand. In these two, there is minus I. Minus I is working in these two. Minus I is working. Minus I is working. And these two, plus I is working. Plus I is working. So more is minus I, better it is. And less is plus I, then it is better. Right? Good. Good. Now, last question on this. Last question on this. No, Kolbe's electrolysis. No, it's decarboxylation reaction. No, very, very important thing. Very, very important point you can say, or important thing you can say, that beta-keto acids. Number of times this thing has been asked in number of examinations, that beta-keto acids. Beta-keto acids undergo decarboxylation simply on heating. Simply on heating. Undergoes decarboxylation simply on heating. Now what is this? Means no soda lime reaction is required. What they are talking about? No soda lime reaction is required. Just heat them and they will lose carbon dioxide. What is this? See to it. Everyone see to it. The question is CH3, CH2, C double bond O, CH2, COOH, and heat is provided. Just heat, nothing else. No NaOH, no calcium oxide, simply heat. This is a sign of heat. Now just see to it. Is it beta keto acid? How to find out is it beta keto? This is functional group. This is your functional group. Adjacent to this carbon is known as alpha and this is beta. So at beta there is keto. So how the reaction will take place? This will be the carbon ion, and just see this carbon ion is stabilized by resonance. If you know resonance, so this carbon ion is going to do resonance with it. So this carbon ion is resonance stabilized. Carbon ion is, as the carbon ion is resonance stabilized, resonance I taught in GOC part 2. GOC part 2. So this carbonyl is doing resonance with this carbonyl group. And you know that if any cation or anion that is being resonance stabilized, that means a lot. So it can easily lose its carbon dioxide. The CO2 will get eliminated out, and this proton will come in the life of this carbonyl. You can see this proton will fly over from there and will come in the life of this. And what answer you will get? You will get CH3, CH2, C double bond O, and H will come at this place. You will get this compound. This compound you are going to get. Now, one question for you people. If they have given you this question, do let me know what answer you are going to get. CH3, CO, CH2, COOH, and simply they have given heat. They have mentioned heat over here. What answer you will get? And they have asked one question based on this. Do let me know in the chat section what answer you are going to get. Killer Science is asking, sir, but when it is attached, it also has tendency to attach on oxalate. Okay, I will let you know. I will explain. Don't worry. Acetone. Very good. Pamela Bridget. Absolutely correct. Now let me explain. This is like this. Okay. This carbonyl is formed. Now what he has written, Killer Science, sir, what? Where it attached, it also has tendency to attach on oxygen also. See, it is attached on oxygen. This carbonyl, it will be formed like this. During the reaction rate determining step, carbonyl is formed. Now CO2 will leave. During the reaction, CO2 will go away. This will be formed as intermediate, and this intermediate, just compare this intermediate and this intermediate. If somebody is giving you these two reactions, its intermediate will be like this: CH3, CH2, negative. Now this compound will say, I don't want to go toward that side. Its equilibrium will lie more in the backward direction. Why? Because this compound will say, I'm to feeling highly unstable. So it will go like this and will come like this. That side highly unstable because no resonance, even though you can say, although this is giving plus side, and that's why it is donating electron and its intensity is increasing, magnitude of charge is increasing. So it will not go in the forward direction, less in the forward, more in the backward. But this is stabilized by resonance. This is stabilized by resonance. So in this case, equilibrium will go more in the forward direction and less in the backward direction, So this reaction will move fast and that reaction will move slow. This reaction slow and this fast. Are you getting my point? Because this is stabilized by resonance. Now proton, just add proton to this and you will get answer. So your answer is, Pamela ji, is absolutely correct. CH3, CO, CH3. Acetone is the answer. Acetone. IUPAC name is propanone. It's everyone is able to understand. Clear. King's Life clear. Jyoti Kumari clear. Everyone. That's really awesome. Fantastic. Now see, this reaction is clear to you. Now let's move towards Kolbe's electrolytic method. For Kolbe's electrolytic method, first I will give you the short trick and then I will explain in detail. Is it okay? First the short trick and then in detail explanation, right? See the short trick. I am going to start with the short trick. So they will give you a question like this. CH3, CH2, COONA. Either they will give you Na or in place of Na they can give you potassium, and here they will write aqueous or they can give water, and then current kids, they will give you current because electrolysis is there, so current is there. So they will give you like this. Wow, Jyoti Kumari ji, it is your first class. You're liking it? Are you liking it? Okay, now see how to deal with this question. Aqueous, not right, let me write down how they can give you the language. Aqueous solution of sodium or potassium salt of carboxylic acid. They can give you like this. This is the question. Question can be provided by like this. Now, how to do it? Just see to it, everyone. What you can do, you take it like this: CH3, CH2, C double bond O, O, Na, 1 mole. One more mole you can take like this: CH3, CH2, C double bond O, O, Na, and then water. They have given water, so take water, H, O, H, H, O, H. Now see the trick, how the trick will work. See to it, everyone, see to it, how the trick will work. Just break it from here. Just break it from here. Break it from here. Right? After it has broken up from here, make a bond. Make a bond of it. Make bond of it like this. The pack. This bond has been formed. You got butane. C4H10. Now, break this bond from here. Break this bond from here. CO2. From here you got CO2. From here you got CO2. 2 moles of CO2 you got. 1 mole of alkane plus 2 mole of CO2. 1 mole of alkane plus 2 mole of CO2. Once again, let me write down 1 mole of alkane plus 2 moles of CO2. Are you able to understand? Here 1 mole of alkane and here 2 moles of CO2. You are getting 1 mole of alkane and 2 moles of CO2. That's C4H10 plus 2 moles of CO2 you got. Both of these two things you have got at anode. Left hand side anode. Do remember, left hand side anode. Generally we used to make left hand side anode. So you got at anode 3 moles of gas, 3 gaseous moles mixture. Now just see to this position, NaOH. You got 2 moles of NaOH. You got 2 moles of NaOH in this solution. 2 NaOH in the solution. In solution. So as the reaction proceeds, pH of the solution keeps on increasing. That's why this question number of times it has been asked, as the reaction proceeds, pH keeps on increasing, because in the solution you are getting NaOH, NaOH, NaOH again and again. Now see to it, H and H, 2 moles of hydrogen you have got, and this will form hydrogen gas at cathode. So hydrogen gas at cathode. So 1 gaseous mole you have got at cathode and 3 gaseous moles you have got anode. And this was the short trick, without using electrolytic tank, without doing electrolysis, without telling you the preference of reduction, standard reduction potential, without telling you the standard oxidation potential value. Nothing I have compared, I have told you by the short trick. Never with 1 mole, it's never possible. Whether they are writing 1 mole, whether they are writing 2 moles, whatever they are writing, this reaction will proceed, this will go like this only. This cannot proceed with 1 molecule or 1 mole. This will proceed like this only. This has to proceed like this only. Okay, now let me tell you the detailed mechanism of it. How the reaction has happened. Now see to it, kids, how the reaction has happened. Let me take the electrolytic tank. Let me take one electrolytic tank. This is electrolytic tank. Let me put anode and cathode to it. Let us say this is anode, and this is being cathode. Now here in electrolytic chemistry, electrolysis, we can say anode is one which is attached with the positive terminal of the battery, and the cathode is one which is attached with the negative terminal of the battery. Okay, so this is anode, that is cathode. Anode and cathode, we knew it. Anode and cathode, everyone knows where the oxidation takes place. This thing everyone knows, where oxidation and where reduction takes place, whether it is electrolytic cell or it is electrochemical cell. Always oxidation takes place at anode. Oxidation will take place at anode. What is the meaning of oxidation? Loss of electron. Now cathode, always reduction takes place. Now what is meaning of reduction? That is gain of electrons. Am I right? Gain of electrons. Now this is the electrolytic tank. Anode we have got, cathode we have got. In electrochemical cell, anode is negative terminal because their electrons are being generated, but here anode is positive terminal. Okay, lone, yes, lone, oil rig you can say, or whatever you can say. Now see, one simple funda: oil, oxidation is loss of electron, and rig, reduction is gain of electron. Rig, oil rig. Now what is there in the electrolytic tank? In the electrolytic tank, we are having CH3, CH2, COO negative, OH negative from water, and we are having two anions. Anions will move towards anode. Simply, this is positive terminal of the battery, positive. So towards positive, definitely negative anions will move towards anode. Both the anions will start moving towards anode. And two cations we are having. Two cations. What are the cations? One is being H plus and one is being Na plus. Cations will start moving towards cathode because this is negative terminal of the battery, right? Now cations will start moving towards cathode. Now it's not possible that both can be the winner here, both can be the winner over there. Both will win. Both the type of entities will start moving towards anode and both type of entities will start moving towards cathode. But who is going to win the race? That depends. See, at anode, this is going to win the race. At anode, this anion is unstable. This is going to win the race. So oxidation. See how oxidation is going to take place. CH3, CH2, COO negative. Let's take two molecules, and two molecules, when they are going to lose two electrons, how they will look like? They will look like this: 2 moles CH3, CH2, C double bond O free radical, and it has lost 2 electrons. So say 2 electrons are over here. Now you know that very well. Carbon dioxide is very good living group. Carbon dioxide, when you open the Limca, Mazda is not having carbon dioxide. Limca, Coca-Cola, whatever, carbon dioxide easily escapes. When the temperature is low, it's okay. Otherwise, high temperature during summer season, carbon dioxide. Carbon dioxide is very good leaving group. Carbon dioxide is very good leaving group. It will leave. Now, you are going to get 2 moles of CH3, CH2 free radical plus 2 moles of carbon dioxide. Now these free radical, once again, do remember, during the Wurtz reaction, I have told you the free radical mechanism. These two free radical can combine in two ways. By two ways, these two free radicals can combine. This I have told you when I was telling you what? Do you remember when I was telling you Wurtz reaction, free radical mechanism and ionic mechanism? The majority is going to form butane, C4H10. This will be your major answer, major product. But by disproportionation, there I forgot to mention word name, disproportionation reaction, because carbon is losing electron and carbon is gaining electron. Carbon is losing hydrogen, carbon is gaining hydrogen. So disproportionation reaction, when same atom, disproportionation reaction, when same atom is losing as well as gaining, it is going to form ethene, and ethene is used for ripening of, yes, fruits, artificial ripening of fruits. The ethane also C2H6. This will be the minor product. So this is all about at anode happened. So what is going to happen at cathode? That out of H plus and Na plus, you know that when you see the electrochemical series, Na plus and H plus, Na is more reactive element, lithium, sodium, potassium, all these are being very reactive element, alkali, alkaline, they all lies above hydrogen in the electrochemical series. Hydrogen has got standard reduction potential value of 0. All other elements standard oxidation potential is very high, and I would like to say that Na plus is not going to take electron. H plus will say yes, this is me, give me these 2 electrons. So these 2 electrons will be accepted by twice of H plus to form 2 hydrogen atom, and 2 hydrogen atoms will combine to form H2 gas at cathode, because gaining takes place at cathode. So this reduction process will take place at cathode. So what is left in this solution? OH negative is left by this, OH negative is being left, and Na plus is being left. NaOH is left in the solution. So during the process, as the process proceeds, OH negative formation takes place, that keeps on increasing, and that's why pH of the solution keeps on increasing during this process. I hope that everyone, it's clear, you are able to understand the whole mechanism of it. Electrolysis, electrochemistry also you are going to study during organic chemistry. If you are liking it, show me thumbs up along with green hearts. By heart, it's going go green that you are liking it. Yes, then let's move towards another reaction if this is clear to each and everyone. Now from Grignard reagent, this Grignard reagent in class 11th organic chemistry, it's not given, but number of times, number of questions they have asked. So what is Grignard reagent? Let me tell you how the Grignard reagent is formed. So let me tell you, everyone see to it. Grignard reagent is an organometallic compound, organometallic compound. Organometallic compound. How it is formed? It will get formed by Rx. This is Rx, that is alkyl halide. This is negative, this is delta positive. Magnesium and dry ether. Magnesium in presence of dry ether. Now it will form RMgX. RMgX. This is known as Grignard reagent. This is known as Grignard reagent, where X can be either chlorine, bromine, or iodine. Because if this is fluorine, X is fluorine, that the reaction is not possible. So X cannot be fluorine. X can't be fluorine. This is Grignard reagent, organometallic compound. Why it is known as organometallic compound? See kids. Organometallic compound means carbon is directly bonded with metal. If carbon is directly bonded with metal, let me tell you the chemistry of it. I've told you number of times. All the teachers will tell you that alkyl is plus I, that is always electron donating. But see, metal says I'm from the family of Karn. Karn, you know, in Mahabharat, the best donor. So I'm not going to take your electron. I will donate electrons. So in Grignard reagent, this act as minus I. Alkyl group act as minus I. Remember that. It's not about the element, it's not about the atom, what actually they are. Where they are located, that means a lot. You know that every cock fights best. Every cock fights best in or on its own dunghill. Have you seen? Have you ever heard this phrase, verb, whatever you can say? Every cock fights best on its own dunghill. So, where it is located, if a man is known by the company he keeps, or the person is known by the company he or she keeps. So, here the carbon is acting as minus I kids. In Grignard reagent, R part is negative and it is electron withdrawing group. Electron withdrawing group. So, in Hindi there is one song, क्या से क्या हो गए देखते देखते, वो जो कहते थे बदलेंगे ना हम कभी, क्या से क्या हो गए देखते देखते. This is song in Hindi. So it all depends that donor has become acceptor. Donor has become acceptor over here. So this is all about Grignard reagent. This is special about Grignard reagent, that donor has become acceptor. Donor has become acceptor. You must have seen one example of Ambani also. One Ambani, another Ambani. One big Ambani, one small Ambani. What has happened? क्या से क्या हो गए देखते देखते. No problem. Now see everyone. So let me tell you about this Grignard reagent. Let me take one example of Grignard reagent, kids. Let me take one example of Grignard reagent. See, if I take this example of Grignard reagent, methyl magnesium bromide, you can see this magnesium is metal. Magnesium is metal, and metals are best. Metals are best electron donor. Once it is donating electron, it has to accept electron, and the one who is accepting electron will develop negative charge. Now, if it is coming in contact with water, water is like this, delta positive and delta negative. This R is delta negative part. This is being delta negative part. You can see very clearly this is being delta negative. So what it is going to accept? What it is going to accept from water? H plus. This and H plus will combine together. Both of them, they are going to form a bond. They will combine together and they will form a bond. What they will known as, it is going to get H plus from it. This is known as active hydrogen. This is known as active hydrogen. Active hydrogen word they are going to use. Active hydrogen. This is known as active hydrogen. So what you are going to get? You will get alkane. You are going to get alkane. Everyone, are you able to understand? Hey, nahi, Jyoti Kumari ji, it's not like that. I can't be the singer. My voice is not good. I used to say all these things just to teach you, just to let you know. Otherwise, I'm not a, you know. But yes, now see, Rowdy Boy Gaming, super explanation. Thank you, Rowdy Boy. Now, see, what you are going to get? You will get CH3NH. CH3NH, what you are going to get? That CH3 and this hydrogen, both together, they are going to form methane. They are going to form methane. And this will combine with magnesium hydroxybromide, magnesium hydroxybromide, magnesium hydroxybromide, hydroxybromide. Now, how the question can come? How the question can be asked on this? See to it, everyone. Suppose if they have given you a question like this, CH3 MgBr, either to they can give you a question like this or they can give you the name. What's the name? Methyl magnesium bromide, methyl magnesium bromide. Methyl magnesium bromide, once it has been treated with water, once it has been treated, that I already have told you, heavy water. This is known as heavy water. Heavy water. Now, kids, do let me know what you're supposed to do. You have to do the same thing. Nothing new. If you know very well this thing, that this is being delta negative and it's like delta positive, delta negative, just form a bond of this to this. What you are going to get? You will get CH3 and D. CH3 and D. This will be your answer. Everyone agreed? Everyone agreed? Now see. If they give you the question like this, phenyl magnesium bromide, phenyl magnesium bromide, its name is phenyl magnesium bromide, phenyl magnesium bromide, phenyl magnesium bromide, and they have added water to it, water to it, water. Now what you are supposed to do, you just take it to be negative and take it to be positive. Just on the negative part, put one hydrogen. Your answer will be definitely benzene. Benzene will be your answer. Everyone agreed benzene. Very good, killer science. That's really awesome. Now, the question arises, simple question, that is this Grignard reagent going to react only with water? No other chemical is there to whom it can form the bond, same type of bond? Yes, kids. Number of things are there with which it can form a bond, like same bond like this, and it can form alkane. Just see to it. Everyone see to it. See to it. Suppose if I say that I am provided with Grignard reagent C2H5 MgBr. MgBr. This is the Grignard reagent provided. And now this Grignard reagent is allowed to react with, this Grignard reagent is allowed to react with water. This Grignard reagent is allowed to react with water. Is allowed to react with water. What's your answer? With water. You know very well, with water, C2H6 will be the answer. Now, if you react the same compound with alcohol, if you react the same compound with alcohol, even alcohol is having proton. This is known as active hydrogen. Either you do hydrolysis or you do alcoholysis. This is known as alcoholysis. Even they can use the word alcoholysis, and over here they can use the word hydrolysis. We should know this is hydrolysis, that is alcoholysis. Same thing it is going to do over here, C2H6 side product, no need. Now if they are giving question, they are reacting with ammonia. Now see, ammonia is, you can write ammonia like this, NH2 and H, this H delta positive, this delta negative. Same thing is going to happen over here also. You will get C2H6 as the product. Now if they are going to give you 1 degree amine, if they are going to give you 1 degree amine like RNH, so see, it is also having active hydrogen. So same answer you are going to get, C2H6. Now if they are going to give you 2 degree amine, now no problem, 2 degree amine also is having 1 active hydrogen. This is also having 1 active hydrogen. Same answer you are going to get, C2H6. Now if they are going to react it with acetylide, CH triple bond CH, now it is having active hydrogen. Once again your answer will be C2H6. Now if they are going to react it with ethyl alcohol, no problem, ethyl alcohol is the alcohol only, and I have told you if you are going to react with alcohol you are going to get same product, C2H6. Now if they are going to react with phenol, no problem with phenol also, because phenol is having active hydrogen. With phenol also you are going to get same product, that is being C2H6. With ammonia it is known as ammonolysis, and with amine it is known as aminolysis, Kids, see, in all these cases you are going to get the same product. What's the product? You are going to get the same product in all these cases. You got C2H6, you got C2H6, over here also you got C2H6, you can see you got C2H6, here also you got C2H6, you can see everywhere you are going to get C2H6, 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 everywhere you are going to get C2H6 as the product, C2H6 as the product. Can you see, kids? Everyone is able to understand? Everyone now. So all these things I've told you about. Now let me give you one question. Everyone ready for the question? Everyone, are you ready for the question? See, if the question is coming C2H5MgBr plus water, no, plus methyl alcohol, what should be the answer? What should be the answer? And if the second question is coming CH3MgBr plus ethyl alcohol, what should be the answer? Now next time it is coming CH3MgBr plus methyl alcohol. Now in these three questions, what is your answer? I want to see whether you are able to understand or not. Otherwise you must be searching for all the questions, where to get questions, and you won't be able to find out the questions. Kids, first answer. Yes, kids, I'm waiting for your answer. Everyone, do let me know what's your answer. Hey kids, do let me know what's your answer. Those who are working hard, they will get the rank. So it's your time. It's your time to work hard. Propane, benzene. How to get benzene? This is ethyl, kids. No benzene at this place. Ethyl, just put at H from here. Ethane. Ethane will be the answer. C2H6. Now here it's methyl. Put this H plus. Methane will be the answer. And here CH3 negative, and this H plus. Once again, methane will be the answer. Everyone, do let me know why you're writing propane. What you are writing propane? Jyoti, Rajshri, everyone is writing propane. Why you are writing propane? C2H5, only the active hydrogen is required. Kids, why you are writing propane? Those who have written, those who have given the answer as propane, why? Kids, that means you are not able to understand this Grignard Reagent one. Ethane, methane, methane, yes. Srinath, absolutely correct. Absolutely correct. Propane to can't be the answer. Clear? Now, if everyone is able to understand, do let me know, then I can move ahead. Thus, ethyl is going to react with this active hydrogen to form the product. This methyl is going to react with this active hydrogen to form the product. This methyl is going to react with this active hydrogen to form the product. It's like this. Everyone, do let me know. As kids, do let me know. Okay, no problem, no problem. You accept your mistake, that's not a problem. Now see, we are going to move towards from carbonyl compounds. See, this is really very important. If we are provided with any carbonyl compound like this carbonyl compound, let us suppose this is R1, this is R2. It can be aldehyde or ketone. It can be either aldehyde or it can be ketone. Aldehyde or ketone. Either it can be aldehyde or ketone. It all depends on R1. R1 can be equal to R2 or R1 cannot be equal to R2. Doesn't matter. R can be hydrogen or alkyl or aryl. It can be anything. Aryl. Now, what is going to happen? See kids, really very important. R1, R2, C, in place of oxygen, two hydrogens will take the position. Oxygen will be replaced by two hydrogens. Oxygen will get replaced by two hydrogen. Now, this can be achieved by three methods. First method is, its name is Clemenson's reduction. Clemenson's reduction. Its name is Clemenson's reduction. What's that? Clemenson's reduction. They will use zinc amalgam, zinc Hg HCl. Whenever this reagent is provided, just think over it that oxygen will be replaced by hydrogen. This is first method. Or if you are not wanting it, you can use another method. See to it. This can also be done by hydrogen iodide red phosphorus. You can use hydrogen iodide red phosphorus, Hi red phosphorus, you will get the same product. Either so you can apply X method or Y method, and if even Y method is also not applied, you can use Z method. If the choice is given, you can use Z method, and this Z method is known as Wurtz-Fittig reduction. Wurtz-Fittig reduction. What is the reagent used in Wurtz-Fittig reduction? Everyone say once everyone say Wurtz-Fittig reduction. The way to learn it, Agent RED is asking how to learn it. Along with me, whenever I'm asking, say along with me. Then if you're following my rules and if you're attending this live class, when I used to say, when I'm telling you, when I'm asking you, Wurtz-Fittig Oh Krishna, you are the greatest magician on this world. Krishna. Wolf, Krishna, reduction. One is Wolf, one is Krishna. Both together, reduction. Wolf, Krishna, reduction. Wolf, Krishna, reduction. So, what they are going to use? Hydrogen, NH2, NH2. This is known as hydrogen. Hydrogen. It takes time. Hydrogen, KOH, along with hydrogen, KOH plus ethylene glycol, CH2OH, CH2OH, ethylene glycol. These many reagents are used in this reaction. Either of 1, 2, 3, any process can be used. Now, how the question can be asked? See to it. How the question can be asked on this reaction. Everyone see to it. The question can be asked like this. If this is given, one easy question, one tough question. Two questions I will give you. One easy question, one tough question, right? Easy and tough. Two types of questions has been asked. Easy and tough. This side easy question. This side tough question. Tough is nothing actually. So, easy question is acetaldehyde CH3 CH double bond O. They have used N2H4 KOH, simply this much. Which reaction is this? What product you are going to get? Which reaction is it and what product you are going to get? Fast. Everyone do let me know. I want the answer. I want the answer. Do it. Hurry up. Fast, fast. Ethane. Very good. Ethane is the correct answer. Ethane is the correct answer. Now, tough question. Tough question is, which reagent is best? Which reagent is best for following conversion? For following conversion. Which reagent is best for following conversion? The conversion given is just try to understand what they have converted, what they are asking to convert. And the options given are, first one, Wolff-Kishner reduction. No. First option was given as zinc amalgam, HCl. Second option was given as HI red phosphorus. Third option was given as methyl magnesium bromide, zinc and water. The fourth option was given as N2H4 KOH. So what's your answer? I want to see what's your answer for this question. Yes, wow. Bidhajani. My pronunciation is not okay, I think. Bidhajanani. Fourth option is correct answer. That's absolutely correct. This is the best answer. See why? We are just supposed to convert this compound, this carbonyl group, into this hydrocarbon, and we don't want to convert. This group should not be affected. This group should not be affected, should be protected. Now, this is basic group, this is base, and base should not react with acid. If it is reacting with acid, say this is acid, it will react with this to do acid base neutralization. This is acid, it will destroy this base, and this is basic reaction. Which one? This is simply basic reaction. So it is not going to affect basic reaction, will not affect OH, will not affect OH. Are you getting my point? Will not affect OH group. So that is the best option. Base will not react with base. Everyone is able to understand. Is it clear to each and everyone? So all this I have completed. Now we have reached towards chemical properties. After all, preparations completed, basic part completed, how these are getting formed completed. Still, are you full on energy? How's the Josh? Kids, if you got tired, then do let me know, but don't do that. Meanwhile, when I'm teaching and in between, you are just going away. Oh, today I haven't asked for the likes. I forgot to hit the like buttons. Yes, I forgot. Now, so anything new you are finding here in this batch, in this session, what are the sessions are scheduled? Are you getting anything new? Okay, that's really awesome. Now see, chemical properties. First, halogenation. This is the most important chemical property. This is the most important one. Halogenation is the most important one. See, everyone. Okay, that's really fantastic. Now see, first of all, let me tell you very simple reactions. Very simple reactions. What are they? Halogenation. Like if we are provided with methane, and if methane has been reacted with fluorine F2 in dark, whether you are reacted in dark or sunlight, what is going to happen? It will form carbon black. That means highly reactive, and that's why fluorination of alkane is not carried out. Fluorine is highly reactive. The reactivity order of halogens is like this. The reactivity order of halogens is like fluorine, then chlorine, then bromine, then iodine. This is the reactivity order, and from the reactivity order you can see very clearly that fluorine is highly reactive. So reaction can't be controlled. Very tough to control this reaction. So this is not the way to prepare fluoroalkane. That's why fluoroalkanes are not prepared by this method. In class 12th, you will come to know that fluoroalkane is prepared by Schwarz reaction. Which reaction? Schwarz reaction. I'm not going to write it right now because it's not required right now. In class 12th, first chapter, I will let you know haloalkanes that it is prepared by Schwarz reaction. But if I talk about chlorination, now see what is going to happen for chlorination. CH4 Cl2 Cl2 Cl2, 3 times I am writing Cl2, Cl2 dark, Cl2 H nu, and Cl2 12 noon. 12 noon. First, no reaction. No reaction. Second, four types of products. Four types of product. What are these four types of products? Once H will be replaced by chlorine, you will get methyl chloride, you will get CH2, Cl2, dichloromethane, you will get chloroform, you will get carbon tetrachloride. Four types of products. But 12 noon, reaction is going to be very fast. Here you are going to get carbon black, carbon black, carbon black. Now, this Cl2H nu, this needs to be more clarity over here. Let me tell you how the reaction, this sunlight reaction, how it proceeds and what other things are required. This needs more detailed mechanism. See, if I say that CH4 is allowed to react with Cl2, what can be used? What can be used to do the reaction? This reaction either can be done by thermally or photochemically. We are going to deal with thermally. Thermally means heat. We have to supply heat. Thermally means heat. Then what temperature is required? What temperature is supposed to be given to this reaction so that this reaction can take place? So just remember what I am telling you. The trick for it is thermally. What is written over here, just to let me know. Then once again I will write. Do let me know what I have written over here. Thermally. Keep in your brain. Thermally. What I have written over here, that is heat, heat, heat. Now what temperature we are supposed to give? Remember TFC. TFC. Just to remember TFC. What is this TFC? TFC means 300 degree to 500 degree. Now what? Kelvin or Celsius? C means degree Celsius. 300 to 500 degrees Celsius, because when the options are given, you will get confused in between degree Celsius and Kelvin. So just to remember one thing, the Celsius. If you want to convert into Kelvin, just add 273 to it. So 500 degrees Celsius will get converted into 773 Kelvin and 300 will convert into 573 Kelvin. So this is thermally. Now, if thermally is not given, you can go photochemically also. This reaction photochemically. How this reaction can move photochemically? They can give you sunlight. They can provide sunlight, or they can write diffuse sunlight. Diffuse sunlight, they can give you diffuse sunlight. Diffuse sunlight. If they have not given diffuse sunlight, what they can give you? They can give you H nu. If they have not given you H nu, what else they can give you? They can give you ultraviolet rays, UV rays. Out of all these things, they can give you something, right? Jyoti Samugdasandram. Very good. Thank you. Thank you for liking my trick. Now kids, this is going to take place, and number of 4 types of products we will get. 4 types of products we will get. 4 types of product. Now kids, what type of question can be asked on these 4 type of product also? See everyone, one question is this: CH4 plus Cl2, and they are writing this is in excess. This is in excess. Another question they are giving, another question is given like this: CH4 plus Cl2. Now Cl2 is in excess. Now everyone, to solve this question immediately, the first question and second question, to solve it, it's very simple and we can do it very easily. Suppose God has thrown the chocolates. 100 people are present over there in the garden, and God has thrown just 100 chocolates. So it might be possible that everyone is going to get one chocolate. But if God is going to throw 1 lakh chocolate, only 100 people are standing over there and God has thrown 1 lakh chocolate, then everyone will be having more than 1 chocolate. But if 100 people are there, God has just thrown 4 or 5 chocolates. Now, everyone can't have chocolate. So once the chocolates are more, once the people are more, it's very simple. Now, once the chocolate are more, here this is more. So major product will be, here this is more. So major product will be methyl chloride because chlorine is less. Here chocolates are more. So every person is going to get more and more chocolate. Agreed or not? This will be major. Everyone agreed or not? Yeah, I can see your answer. Kid took chocolate, not people. Oh my god, everyone is kid. First, listen properly. Mark my words. Everyone is kid. Every person has kid. Yes, hidden in the life of everyone, every person, whether so big people, so small people, whatever the number of, whatever the people are there. Kid Bhumi Kataria, welcome Bhumi. So late, no problem. Now see. Now let me give you one question. See to it. Everyone see to it. Just see to it. See. Question is, find out number of types of products. Now the reaction is C2H6 plus Cl2 sunlight. Just try your level best and try to find out how many types of products will be formed during this reaction. Just try to find out the answer. How many types of products do you think will get formed during this reaction? Everyone. Yes, 4 types. King Life is saying 4 types. Kids, try to find out. This question has been asked. So I want to see the correct answer. This question has been asked. Find out number of types of, or this question can be asked like this also. Find out maximum number of all types of chlorinated products. Find out maximum number of all types of chlorinated products. This question can be asked like this also. No one's answer is correct. Now let me tell you, the answer is Answer of this question is 9. Answer is 9. See how and why. Everyone, see to it how and why. CH3, CH2, CH3, CH, CH3, C, CH2, 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 CH, 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 C, C, C. Now see to it, everyone. Cl, 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 Cl. No product is getting repeated. See to it. If it is getting repeated, do let me know. But I am 100% sure that not a single product is getting repeated. So these are 9. All 9 types. Yeah. Hitesh, Sonwan, definitely you can ask one question, 2 questions, whatever the number of questions, but write down fast so that we can move fastly. So the answer is 9. But kids, don't do for propane, butane, because this 9 has taken too much time. It took too much time. So not beyond that. Methane and ethane only 2. Methane and ethane only 2. So always remember, for this the answer is 9. Now let me deal with rank deciding concept. Everyone ready for the rank deciding concept? Everyone, are you ready for the rank deciding concept? Now see, we are going to move towards rank deciding concept. Everyone see to it, rank deciding. So everyone ready? Is everyone ready? Ready, I can see ready. Now see the mechanism. We are going to deal with the mechanism of halogenation. Mechanism of halogenation. So for this type of reaction, halogenation is the most important thing, because alkanes are not that much polar, just like alkyl halide, very big chapter. Alkene, alkyne, it's okay. Alcohol, big chapter. Phenol, big chapter. Amine, big chapter. But hydrocarbon, if we talk about alkane, these are very, very less polar. So they do not show most of the reactions. So for these, halogenation is the most important one. Now, see to it, mechanism of halogenation. Halogenation follows free radical mechanism. Halogenation follows free radical mechanism. And this mechanism is given in your NCERT also. And this free radical mechanism takes place in 3 steps. Now, what are these 3 steps? One is chain initiation. Say everyone along with me, chain initiation. The first step is chain initiation. I will let you know in detail. Second step is chain propagation. Then only you can keep it in your brain. For long lasting memory, you have to say along with me, chain propagation. If you are doing the procrastination, that I will I will start tomorrow, day after tomorrow, day after tomorrow, tomorrow. Tomorrow is not going to come. Right now, you have to speak, you have to say, you have to revise along with me. Chain propagation, chain initiation, chain propagation, chain termination, chain termination, termination. Because if you're thinking that why to speak, why to say, why to revise, along with our brain, our body also learn. You just see in the starting when you have started learning about the scooty, you won't be able to apply in the bike, on the scooty, brake, clutch and accelerator all together, or the car. But now your body has learned without applying your brain. Yeah, I'm not saying you are not applying your brain, but brain is not going to send the message. It's a reflex action without sending message. I'm not saying sending message. This can be very fast process or the reflex process. You're not just thinking where's the brake, where's the clutch, where's the speed, accelerator. It is applicable all by its own. On halogenation, an alkane gives only mono one halogenated product. No, it's wrong. On halogenation, an alkane gives only one mono halogenated product. That question is like, let me tell you, Hitesh, your question will be like this. Let me tell you what Hitesh is asking. That question is framed like this. See, if the question is coming in your exam like this, Hitesh, see to it, find out mono halogenated products for each. Now, if they are saying just we are supposed to put one chlorine, one halogen, we cannot put more than one halogen. Now, see, for methane CH4, the answer will be methyl chloride, only one. For ethane, answer will be CH3, CH2Cl, wherever the side you can put only one. For propane, CH3, CH2, CH3, it will be two types, CH2Cl, CH2, CH3 and CH3, CH, Cl, CH3. So 2 is the answer. But in the question they haven't said all possible type of halogenated products. Now see, the question find out monohalogenated. If monohalogenated is mentioned, then you can place only one halogen. Then this is the answer. Is it clear, Hitesh? Is it clear? You got it? Absolutely correct? Satisfied? Okay. Now kids, students are getting decreased. I think for them, this much time they cannot study. Now, everyone try to call other students also. See, only 28 are left. Only 28 are left. Kids, we have to work hard. Otherwise, people will say, if you have studied hard, you would have become a successful doctor. Don't be like that. Everyone should say that you are really the successful doctor because you have studied hard. Now see, kids, I was telling you the mechanism. So chain initiation, chain propagation, chain termination. 3 main steps for this: chain initiation, chain propagation and chain termination. Everyone, can you keep it in your brain? chain initiation, chain propagation, chain termination. Now let's start. Let us take this reaction. C2H6 plus Cl2H nu. What the product are going to form, how these product will get formed. Now see, first step is chain initiation. Chain initiation. What happens? What is special about it? What's special about it? Chain initiation step. Free radicals are generated. Free radicals are generated. There is origin of free radical. In this step, free radicals are generated. How the free radicals are getting generated? See, if this is halogen Cl2, you can see the electronegativity difference in between two chlorine is 0. No electronegative difference. Once there is no electronegative difference or very less electronegative difference, then these two electrons, they are forming a bond and there will be breaking like this. This is the arrow, and this arrow is indicating that this chlorine has taken one electron and this chlorine has taken one electron. Homolysis, homolytic cleavage. You can see homolysis or homolytic cleavage, and this is known as fish hook arrow. What? Fish hook arrow. This is known as fish hook arrow. Now see, during homolysis, there is birth of two chlorine free radicals. Two chlorine free radicals got generated. In the chain initiation, this will happen. Just this will happen. Chain termination, most of the free radical gets consumed. Now, what happens in propagation? That matters a lot. Now see, chain, your battery got discharged. What happened, kids? What happened? Your battery got discharged. Which battery? Body battery or the mobile battery or PC battery? Okay. Now see, this happens in the chain initiation. Now, propagation. Propagation takes place in two sub-steps. Propagation will take place in two sub-steps. Let me tell you what are these two sub-steps. Chain propagation. Second one is chain propagation. Chain propagation will take place in two sub-steps. That's really very important. Two sub-steps. Sub-step number 1. Sub-step number 1. There was CH3. The chlorine free radical will come near to this. Now it is having two options. This chlorine free radical can take away this hydrogen or it can form a bond with this ethyl. Now let me write down both the two options. What chlorine can do. If chlorine is taking this hydrogen, now this will form ethyl free radical CH3, CH2 free radical, and HCl will get formed. HCl. Or if chlorine is forming bond with this, then you will get CH3, CH2Cl, and hydrogen free radical you will get over here. Now it all depends which bond is more stable. Chlorine is more satisfied with this carbon, or chlorine is more satisfied with this hydrogen, where the stability of chlorine is more. Everything happens for the stability. Chlorine just forming a bond for the stability, and experimentally it is found that its bond stability is more. Experimentally it is determined bond stability is more. Now you will say, where we can find this thing? It all depends the bond energy. This bond energy is more. If bond energy is more, that means more energy has got released during this formation, and formation is with least energy means most stability. But no need to go for that. Just remember that this process is more feasible, or you can say for this process activation energy is low, so this process will take place, and for this activation energy is very high, and so this will not take place. So we have to go for this, and in this step ethyl free radical, that means alkyl free radical, is formed. Are you getting my point, everyone? So during sub step number 1, alkyl free radical is formed. Alkyl free radical is formed. Do remember that. And this sub step is really very important, because in this step free radical is originated, free radical is formed. So the rate of reaction is directly proportional to the stability of free radical. This is the very important point. Rate of reaction is directly proportional. So I can say, or you have to say, rate of FRSR, free radical substitution reaction, is directly proportional to the stability of free radical. Stability of free radical. Now, once the free radical is formed, you have to think about whether that free radical is more stable or less stable. If more stable, so more easily it can form, and more will be the rate of reaction. This is the important point to be noted, all my dear friends, that rate of reaction is directly proportional to the stability of free radical. Now sub step number 2. Sub step number 2, always try to find out what's going on. Sub step number 2. Sub step number 2 of propagation. Propagation sub step number 2. This sub step is of propagation only. Propagation. Once we have got ethyl free radical, CH3, CH2 free radical. Now this free radical will break this chlorine free radical. Once chlorine free radical was formed by sunlight. Now once the sunlight is removed, then also the reaction will keep on continuation, because now this chlorine free radical is going to broken up by this ethyl free radical, and this will take one electron. This will take one chlorine along with the electron, and the bond is going to get formed, and you got the main product over here as CH3, CH2, Cl. So in chain propagation step number 2, sub step number 2, one of the main product is formed. Main product is formed over here. Main product has been formed. Now see termination. What is going to happen? Chain termination step. Chain termination, the third step. It can have number of things, but all the things for chain termination, let me tell you, chain termination, all the thing is working for almost all the free radicals, almost all the free radicals will get consumed. All the free radicals will get consumed. How they are getting consumed? Will get consumed. Now see to it. What can happen? This chlorine free radical can combine with this chlorine free radical to form Cl2. This can happen. This could take place, isn't it? This methyl free radical, no, ethyl free radical, this ethyl free radical can combine with ethyl free radical. This could happen to form C4H10, and if disproportionation is taking place, disproportionation, I have told you in Wurtz reaction, I have told you in Kolbe's reaction. So this is going to form CH2, double bond CH2 plus ethane C2H6, and this ethyl free radical can combine with chlorine free radical to form the main product once again. Ethyl chloride can get formed. So these are the possibilities. How many possibilities I have told you in termination? A possibility, B possibility, C possibility, and D possibilities. So these four possibilities are possible for this reaction. Kids, are you getting my point? Wow, that's really awesome that I can see most of the students, they are writing the product, they are taking part once I'm asking the question. This is really a good sign of a good student. Really, if you're working hard, your success is waiting somewhere. Now kids, are you interested? Should I tell you something about top 100 rank? Concept for top 100 rank? Top 100 rank. Would you like to go for top 100 rank? How many of you are ready? Show me the hands. Raise your hands for top 100 rank. For top 100 rank, kids. For top 100 rank. For top 100 rank. For top 100 rank. Everyone. Wow, that's really awesome. Really awesome. Now see, if I talk about the reactivity, chlorine is too reactive. So people avoid it. Chlorine, bromine, and iodine is very, very less reactive. So people, they are not going to deal with iodine. So generally you must have seen that people are going to deal with chlorination and bromination. They are not going to deal with this chlorination, explosive. This is explosive, can't be controlled. So its reactivity too much, and this is too slow. So not be done. Now out of chlorine and bromine, mostly the reactions you can see, they are going to deal with chlorination and bromination. So let's see to it. Chlorine is highly reactive, less reactive. Now kids, when your school time, during your class 6, 7th, 8th, once if you are very hungry, you are starving, then you are not going to see whether ma has given paratha, idli, sambar, bada, along with sambar, chutney is there. You will keep on eating. But once you are not feeling hungry, then you are too much choosy. Oh, in the sambar, these sticks are there. Which stick? Drumsticks are there. I don't like. Tomato is there. Oof, tomato I don't like. In the samosa, oh, what type of potato is this? It's too much salt is there. You will keep on saying like this if you're not hungry. Once if you are very hungry, you are less selective. Once if you are not hungry, you are highly selective. So chlorine is highly reactive, so less selective. Highly reactive, so less selective. And this is less reactive, so more selective. The one who is highly reactive is less selective. The one who is Less reactive is more selective. Are you getting my point? Everyone, are you able to understand what I am saying? Now see everyone. Try to understand what does it mean. I'm going to draw one box. I'm going to draw over here one box and try to find out what this box is trying to say. What this box is trying to say. What this box is trying to say, just try to understand. Cl2, Br2, 1 degree hydrogen, 2 degree hydrogen and 3 degree hydrogen. 1 degree hydrogen, 2 degree hydrogen and 3 degree hydrogen. Can you see? Is it visible? 1 degree hydrogen, 2 degree hydrogen, 3 degree hydrogen. Now, if I say its reactivity 1 degree hydrogen, 2 degree hydrogen and 3 degree hydrogen. Its reactivity for 1 degree hydrogen is 1, then this is 3.8 times more. It is experimentally determined, and this is 5 times more. And for bromination, I would like to say if this is 1, then this is 82 times more, and this is 1600 times more. That what does it mean? How the question will come based on it. Now, this data is experimentally determined. Let me tell you, this is experimental determined data. Experimentally determined data. Experimentally determined data. Now, you have to learn it. You have to cram it. Cramming is required. Just try to keep it in your brain if you want to get 100 rank. Now, how this data is going to play the role. Now, see, if question is coming like this, CH3, CH2, CH3 is going to react with Cl2, and you are supposed to find out the monochlorinated product. Now you will get two types of monochlorinated product. One is CH3, CH, Cl, CH3, and another product you will get CH3, CH2, CH2Cl. Now, if they are asking which one is the major, definitely you will say this is 1 degree hydrogen, 3, and this is 2 degree hydrogen, 1 degree hydrogen, 1 degree hydrogen. So definitely 2 degree free radical is more reactive. This is going to be major product. But sometimes they used to say, they ask the question, what is the percentage of this product? Let me tell you, this major one is X, this is Y. Just try to find out the percentage of X. See what type of question has been asked. What is the percentage? Reactivity increases along stability of free radical. Is this conclusion from table? Yeah, but from this table, yes, stability also, but this table is going to help you solve this question. Find out the percentage of these isomers. This table is going to help you in finding the exact percentage. This table is going to help you in finding out exact percentage products. Now see how to do it. Just see in the reactant. Always see in the reactant how many 1 degree hydrogens are there. In the reactant, 6 primary hydrogens are present, right? And in the reactant, 2 secondary hydrogens are present. Agreed? Everyone agreed? Now, just to find out percentage of X, draw one line. We all know very well, above this line is numerator, down the line is denominator. Numerator, denominator, whatever you are going to write, just multiplied by 100. This is the way you are trying to find out the percentage of your marks from your childhood. Whatever you got, the marks you got in the numerator, the total marks in the denominator multiplied by 100. Now see what to keep in the numerator. That would say very important thing. Now see, here the chlorine is placed on secondary hydrogen. So secondary hydrogen, wherever the chlorine is placed, that will come on the numerator. Now see, in the reactant, how many secondary hydrogens? In the reactant, just see in the reactant, 2 secondary hydrogens. So just put 2. Why 2 has been placed? In the reactant, there are 2 secondary hydrogen, and we are going to calculate the percentage of this thing where the chlorine is attached. It is attached to the secondary hydrogen. Now you are able to understand why I have written 2. Now 2 multiplied by 3.8. Now from where this 3.8 has come? From where this 3.8 has come? Now see, this 3.8 has come from here. For 2 degree hydrogen, the chlorination reactivity is 3.8. Are you able to understand, kids? Everyone is able to understand. 2, from where 2 has come? 2 has come from here, and reactivity is 3.8. Till now it's okay. Now downside also you have to write the same figure, 2 into 3.8 plus sign. Now there is 1 degree hydrogen, how many? 6. And what is the reactivity for 1 degree hydrogen of chlorine? See, reactivity of 1 hydrogen, 1 only. You can see 1 only. So I will put 1 over here. See, I will put 1 over here. Now this is the way you can find it out. Now see how much it is going to come. Let me apply maths. 3.8, 3, 8 to just 16, 6, 3 to just 6, 1, 7, 7.6 divided by 7.6 plus 6. So 6 plus 7, 13, 13.6. Am I right? 13.6 multiplied by 100. Just calculate it. How much you are going to get? It will be somewhere 54 to 14 table, you know, 14. So 54, 55, 56%. Just do with the calculator. It's 54, 55, 56 like that. How much it is coming? How much it is coming, kids? Approximately 55%. So approximately 55%. So do you like it? Did you like my maths, kids? Okay, 55.6%. So approximately 55 to 56%. Yeah. So this is 56. Then definitely that is going to be 44%. Now, where it becomes risky, just see where it will become risky. See the question, toughest question, anaconda question. See to it, one anaconda question. There it is going to be risky. Now see to it. If the question is given like this, CH3 hydrogen, and now the chlorination is carried out. Cl2H nu. We are going to get 2 types of product. One is CH3, Cl. Let us suppose this is A product, and plus CH3, CH2, Cl, CH3H. This is B product. What do you think, which is major? Which is going to be major, A or B? Kids, do let me know. What do you think, which is going to be major, A or B? according to you, which is going to be the major product? A. B. Bhumi is saying B. King Live is saying A. Let me check it out what others are saying. See kids, definitely I have told you, I have informed you, I have given a hint that it's an anaconda question. That's why. So anaconda means easy, looking easy, but it is going to bite you. Anaconda means looking easy. Anaconda question means looking easy, but it's not easy. 99.999% people definitely they will write A is major. This is major. Now just try to find out why this is major. Let me calculate its percentage. Let's find out the percentage. Let's calculate the percentage of B. And this question will show you the unity has strength. That slogan you must have heard, that unity has strength. So you can check it out. There in the reactant 1 degree hydrogens are how much? 1 degree hydrogens are 9, total 9, and 3 degree hydrogen is just 1. You must have seen Discovery Channel that 1 lion and 9 buffaloes. Sometimes buffaloes, they are going to kill the lion because they are more in number. This happens. Otherwise, maximum time lion is going to kill the buffaloes or the ox. But if the number of buffaloes is more, now see kids, 9. This chlorine is attached to 1 degree carbon. If it is attached to 1 degree carbon, so let me count 1 degree carbon, 1 degree hydrogen in the reactant, 9. So 9 into reactivity is just 1. So 9 into 1 I will write. Now plus. Put plus sign. Now there is only 1 3 degree hydrogen. So I will multiply 1 into 5. Why 5? See, because the reactivity of 3 degree chlorine's reactivity for 3 degree hydrogen was 5 times more. So I have written 5. Now multiply by 100. Multiply by 100. What you are going to get? Do let me know. 9 upon 14 into 100. That means 900 upon 14. Just do you know the table of 14? 14 6 ja 84. 14 6 ja 84. So more than 60%, 64%. See, Bhumi has done it, 64% kids. Now can you see that one side 9 hydrogen, one side 1 hydrogen, even though the reactivity was more, but it's the winner. So this is really super awesome question, and that this question is going to change the game. This question is the marvelous question, super awesome question kids. That's why this thing is required. Now let me tell you, by bromination is the king or more selective. Even if I am going to do this question from bromination, see, if I solve this question for bromination, what answer you are going to get for bromination? CH3, CH, CH3, CH3, Br2 sunlight, H nu, whatever I am writing, CH3, CBr, CH3, 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 CH2Br, H, CH3. Now let us suppose this is M and this is N. Now let me calculate the percentage of N. Percentage of N. Earlier it was more, but now see, For bromination, if we talk for bromination, that it's 1 degree. So 1 degree, hydrogens are 9, reactivity is 1 upon 9 into 1 plus. Now, although it is 1 only, but its reactivity is 16 times more, 1600 times more into 100. Now, 100 will get cancelled out. This 100 will cancel out. So, 9 upon 9 and 16. 16 plus 9, 25. So, what you are going to get? How much you are going to get? 9 upon 25. What is the percentage? What is the percentage? What is the percentage? See kids, 9 upon 25 is how much? Just 0.36%. 0.36%, approximately equal to 0, negligible. 0.36% is nothing, and that's why bromine is highly selective. Bromination is highly selective. It is said to be highly selective, kids. Everyone, are you able to understand? Kids, do let me know. Everyone clear with this? Everyone is able to understand? Now see, this is really awesome. This is really awesome. Now see to it. Now, controlled oxidation. Controlled oxidation. See kids, 4 reactions are given in NCERT for controlled oxidation. These reactions you have to, sir, but how did we cancel 100? That 100, let me see. See, these two 0, these two 0. These two 0 got cancelled out. Isn't it? Am I wrong? Bhumi, is it right? This 100 and this 100. 100 and 100 I have cancelled out. It's not addition. Oh, yes. Okay. I'm wrong. Wait. This is wrong. It was in plus. So let's do it once again. You are right, Bhumi, you are right. Absolutely correct. And thank you. Thanks. So what I have written, we are supposed to calculate for this 1 degree. 9 hydrogens, 1 degree, 9 into 1, 9 plus. Now, this is 1 into 16. Yeah, what I did, I will let you know. Why I have cancelled out? I will let you know why I have cancelled out. Let me show you. For what I have cancelled it out. In 200. Now see, 9 upon 1600 plus 9. Nothing. It's, let's say 1600 only. Let's 1600 plus 9 is just approximately equal to 1600 only. So I can keep 1600 just for making calculation fast. And that's why I've done it like this. 9 upon 16. So just to make the calculation fast, I have done like that. See my maths, Bhumi, agreed? My maths, agreed or not? And I started thinking what I have done, but yeah, definitely I've done it fastly. Now see, halogenation. If we deal with this question, see, CH3, CH2, CH3, chlorination, and we have got the major product like this. This already we have done, CH3, CHCl, CH3, and this was the major. Percentage was approximately 56. But if the same reaction But the same reaction, we are going to do the bromination for it. CH3, CH2, CH3, Br2, bromination if we are going to do. See, there will be a drastic change in the percentage. Now you will come to know why this reaction is known as highly selective. Find out the percentage of it. Let me do it. Let me do it. Percentage of this major product. Percentage. So I have to draw a line. I have to put 100 multiplied by 100. Now in the numerator, 2 degree, 2 degree, 2. And the reactivity for 2 degree, it's 82. So let me keep 80. 82s are 16, 160, and plus 1 degree are 6. So 6. So let me keep 82s are 160. This is also 160. 160 upon 166 and 200. How much it will come? Thank you, Sayam, Anam. Thank you, kids. Really, if I am working hard, you are working hard, our selection is waiting somewhere. 99.99. Now, see, kids, you can see one more comparison. This is major and that is also major. But this major is 99.99% and that major is just 56. And that's why once again I will say this is highly selective. Bromination is highly selective. That is highly reactive. One more comparison is there. Yes. Always it happens like this only. Now let's deal with controlled oxidation. Now see kids, 4 reactions are given in NCERT based on controlled oxidation. 4 reactions, total 4 reactions, and just keep it in your brain. These all 4 reactions are really very important. So let's see these 4 reactions. It's very tough to keep in your brain. It's very tough. Suppose if I write C2H6 or CH3, 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 CH3. And if I'm going to treat this ethane with copper, oxidation of it in presence of copper. In presence of copper, we are going to treat it doing the oxidation. We'll get alcohol with same number of carbon. Do remember, alcohol with same number of carbon. Then I will let you know the trick. First try to understand alcohol. Now, if I am going to treat the same reaction with molybdenum oxide, catalyst molybdenum oxide, MO2O3, oxidation in presence of molybdenum oxide, we'll get aldehyde of same number of carbon. We are going to get aldehyde with same number of carbons. Now, if we are going to treat this in the presence of oxygen with manganese acetate, CH3, COO, whole twice manganese, then we'll get acid with the same number of carbon. We will get acid with the same number of carbon. Kids, first of all, try to see whether in your NCERT is given this or not. It is given or not, just try to find out. And one last reaction for alkane, and this happens with tertiary butane only, with no other alkane, CH3 plus KMNO4, you will get alcohol of same number of carbon. Just try to find out these 4 reactions are given in your NCERT or not. These 4 reactions are really very important. Let me have a glass of water. Just you see to NCERT whether these 4 reactions are given or not, because these reactions are really very important. And do let me know if you are going to get these reactions. Kids, everyone, do let me know. without heat, without heat. Yeah, definitely, Srinath. I will send the PDF of the previous lecture and this lecture after, right after this session. Okay. Now, everywhere heat is also there. Without heat, these reactions are not possible. So, heat is everywhere. Heat, pressure also, heat, heat, heat. Now, how to learn it? How to learn it? How to remember it, where you are going to get alcohol, where aldehyde, where acid. Now see, if you are going to do oxidation of alcohol, you will get aldehyde, and oxidation of aldehyde, you will get acid. This is the sequence. The oxidation follows this process. So this too we know very well. Now just try to learn these three. Come on, just learn. Come on, man, and check the taste. Have the taste. Come on, come on, man, and have the taste. Come on, come on, man. Yeah, it's class 11th. It's given in class 11th, part 2. Class 11th, part 2. At the last in hydrocarbon. Come on, man, and check the taste. Acetate. Come on, man. Just learn it. Everyone, and do let me know how is it. Come on, come on, come on, come on, come on, come on, man. Come on, man. Come on, man. And alcohol, aldehyde, acid. Alcohol. Yeah, right now I made it. Right now I made it. Yes. Up here, be right now. Come on, man, and check the taste. Acetate. Last reagent is KMnO4. This is being KMnO4 heat oxidation. KMnO4 potassium permanganate. K, it is pink colored or red colored. KMnO4 potassium permanganate. KMnO4 potassium permanganate and heat. Come on, man. Come on, man. Check the taste. Acetate. Come on, man. This is the trick. Everyone, now. See to it. Next, isomerization. Whenever any alkane is given, for example, it is given like CH3, CH2, 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 1, 2, 3, 4, 5, and 6. Now, if they are adding anhydrous aluminum chloride, this is the rarest asked question. But anyways, they are asking this question. By chance, this question has been asked. Do the isomerization. This is the chain of 6 carbon. Now, 6 carbon PC. This is the 6 carbon parent chain. What you are supposed to do? You have to make 5 carbon parent chain. 1, 2, 3, 4, 5. Now just do the numbering. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now one methyl is left. What you can do? Either you can place that methyl at second position, or you can place that methyl at third position. These are the two possibilities. 1, 2, 3, 4, 5. You can place that methyl at the third position. 1, 2, 3, 4, 5. It should be given like this only. Nothing else, nothing new. It should be given like this. Are you getting my point? Now, after this, just keep your NCERT along with me. Aromatization. Just keep your NCERT along with yourself and see to it. This is really important. Aromatization. They have given like CH3, CH2 whole 4, and CH3 and hexane. Now it's very simple that on aromatization it is going to give you aromatic compound of 6 carbon, that is the benzene only, nothing else. But what is important thing about the reagent, what particular reagent you can use. Now kids, try to find out what reagents are given in NCERT. Let me check it out whether you are there with your NCERT or not. Have you opened up the NCERT or not? Let me check it out. Everyone, try to tell me what reagent can we use. Cr2O3, very good. Vidhanjani, very good. V2, Cr2O3, V2O3, and one more is there. One more, molybdenum. Yes, molybdenum. Now, how to learn it? Cr2O3 or V2O3 or molybdenum MO2O3. How to learn it? How to learn it? Is there anyone is having any trick for it? How to learn it? Yes? Yes? Cr, cruel. V, vanadium. Crow, 5. Crow, 5th. Moly. Yes? Molybdenum. Moly. How is the trick of this Bhumi? Bhumi has definitely done a great job. Crow, 5 moly. And aromaticity. Moly is what? Cr for crow, 5. Crow is having 5 moly. Crow is with 5 moly to give aroma. Now, NCERT is asking if you are using in place of N-hexane, if N-heptane has been used, what you are going to get? N-heptane. Definitely, if you are using N-heptane, you will get one more carbon, and that the answer will be toluene. Definitely, the answer will be toluene. Of course, why not? This is going to be the answer. Everyone, crying very mild. Wow, Srinath, crying very mild. This is also very good. Crying very mild. Srinath and Bhumi, really genius. Crying very mild. Benzene, crying very mild. Awesome. This is one, and this is second one. Crying very MO. Monday. Crying on every Monday. Crying very mild. Crying on every Monday. Now that's really fantastic. Now see what we were trying to find out. Aromatization is done. Now combustion and pyrolysis. Kids, in your NCERT, combustion and pyrolysis must be given. So could you find out any difference in between combustion and pyrolysis? Definitely, there is a very big difference. Now, if we talk about combustion, let us suppose whenever we are going to deal with combustion, we are going to add carbon dioxide, water, and lot of energies. For example, if I write C2H6 plus O2, if combustion is done in the excess of air, definitely what we are going to get? Carbon dioxide and water. with lot of amount of energy. The product will be carbon dioxide plus water plus lot of energy. And if anyone wants to balance it, definitely we can balance it. C2, 2 carbons, so 2 carbons I have to put. Now hydrogen 6, so 3 hydrogens I have to place. Now oxygen, 2 to the 4, 3, 7, so I can write 7 divided by 2, it will become 7. This is the balanced reaction. So nothing to be done over here. Now what is the pyrolysis? What do you mean by pyrolysis? Pyrolysis means breaking of higher hydrocarbon into lower one. What is pyrolysis? In the presence of excess of temperature. Do remember what temperature. There it was TPC, here it is FFC. This much of temperature. What does it mean, FFC? FFC means 500. Why I have written FFC? FSC. It was supposed to be FSC. FSC. No, FSC means 500 to 700. Now Kelvin or degree Celsius? Degree Celsius. This I can convert. 773 Kelvin to 973 Kelvin degrees Celsius temperature. And this much temperature, not only the temperature, along with some catalyst must be required, breaking of higher hydrocarbon to lower one on higher heat. Yes. Now see, Srinath, whether any catalyst is required or not, do let me know. No. So see, breaking of, it's given in NCERT only, breaking of higher hydrocarbon into lower one so this pyrolysis sometimes also known as cracking. This is also known as cracking, and this is really going to help in nitration. Only nitration is left. Rest of the things we have completed. One more thing is left. Just try to find out in NCERT what is left. What is left? Try to find out in the NCERT. In the chemical properties, one thing is left. What is that? Reaction of hydrocarbon with steam. Reaction of hydrocarbon with steam. See, I know each and everything, even the single line of NCERT, reaction of hydrocarbon with steam is there. Just try to find out, it's given over there. Yeah. So that you can do yourself. Now let me tell you the last thing. Reaction with the steam. Okay, let's do it. It's written, I have written the heading CH4 plus H2O. Is it going to react with very high temperature? How much temperature? Kids, do let me know. This temperature though is really going to play a very, very important role. How much temperature? Kids, do let me know. How much temperature? Or catalyst? How much temperature? I to think 1000 degrees Celsius. 1000 degrees Celsius, or at 273, 1000 plus 273 Kelvin, that is 1273 Kelvin, and nickel as the catalyst. What is going to happen? This oxygen will be captured by this. Oxygen will be captured by carbon at this much of temperature. Or should I tell you one trick for it? Should I tell you how to learn it? How it is going to help you in inorganic chemistry also? How it is going to help you in your inorganic chemistry also? How many of you want to know this? How many of you want to know this? This is lab method or commercial preparation of hydrogen gas. See in NCERT, it's written over there, commercial preparation of hydrogen gas. Okay, let me tell you, see kids. Now today I am going to tell you the very important thing. This is carbon, this is oxygen, this is CO2. This we know very well. This we know very well. And the energy liberated over here for this reaction delta H is minus 400 something kilojoule per mole approximately. Now, if I write this reaction, see to it, C plus half O2 gives CO. Have you seen this reaction ever taking place? For this delta H is minus 100 kilojoule per mole approximately. Now kids, when you are going to deal with inorganic chemistry, thermodynamics or Alkane diagram or metallurgy, always remember that this reaction takes place at high temperature, just like 910 degrees Celsius it starts forming. Now how to explain it thermodynamically? At low temperature this reaction forms, and that's why whenever there is fire, people die not because of that fire, mainly because of the carbon monoxide produced at very high temperature. And that's why whenever there is fire, always take hanky, dip in water and put it on your nose, so that you should not come in contact with carbon monoxide. We to know very well that insufficient oxygen supply, carbon monoxide is formed, but we don't know at very high temperature, even there is excess supply of oxygen, carbon monoxide is going to get formed. Now see what's the reason. Reason, let me give you from the thermodynamics. Here, this is solid, this is gas. 1 mole of gas is converting into 1 mole of gas. If I talk about thermodynamics, that 1 mole of gas is converting into 1 mole of gas, that delta S changes nothing, because 1 mole of gas is converting into 1 mole of gas. So for the first reaction, delta S changes approximately 0, but because they are forming a bond, so delta H is negative for this reaction. So this reaction is mainly governed by delta H. This is in favor of this reaction. So delta G, Gibbs-Cell mole equation, is equal to delta H minus T delta S. This is mainly governed by delta H. That's why delta H value is very high for this reaction. But if you see for this reaction, this is solid, this is solid, this is solid. Half mole of gas is going to get converted into 1 mole of gas. That's really fantastic thing. 1 mole of gas, half mole is converting into 1 mole. That means delta S is positive for this reaction, it is in favor, and bond is forming. Delta H is also negative, but both are in favorable, but delta H value is less. Delta H value is not more prominent there. Delta H value was more prominent, but here delta H value is less, change is less, magnitude is less, magnitude is less, magnitude is less. So who is the, in this reaction you can see temperature is the friend of change in entropy. Temperature is the friend of change in entropy. So if you increase the temperature is friend of entropy. This magnitude change is major, drastic change in magnitude of this, drastic change. So this delta H will lose, and it is going to lose the match, it is going to win the match. And this is the only reaction in the world. This is the only reaction, one reaction in the world where delta H is negative and delta S is positive. Otherwise, if this is positive, this is positive. If this is negative, that is going to be negative. This is the only reaction in this world. Carbon monoxide formation is the only reaction in the whole world, universe, that where delta H and this is both favorable. This is the only reaction which is going to form bond. Other reactions, bond is breaking at high temperature. This is the only reaction whose bonding starts at high temperature, whose bonding starts at high temperature. And that's why this time also they have given one question of blast furnace. Earlier also they have given one question of blast furnace. Do you remember? Kids. Kids, how much you liked it? This thermodynamic detailed explanation. You liked it or not? You liked it or not? Did you understand? Have you understood, kids? Do let me know, everyone. Have you understood it? Killer science, it's awesome. So, now only one thing is left. Are you ready? Only one thing is left. If you just give me 10 to 15 minutes, I will explain nitration. This is the only one thing. This is the only one thing which is left in this chapter, alkane. I promised alkane. See, I've started at 6. This session, yes, it has been started at 6 and now it's 11:38, 11:40. Approximately, you can say it is going to take 6 hours, but I have told you each and everything. I haven't left even a single word. You can check your NCERT, you can check any question. Each and everything I've told you in detail. Now, nitration. Only one thing is left, nitration. Without this, I'm not going to end this session. Nitration is very, very important. Let me tell you about nitration. See to it, nitration. No secrets. If I take methane and if I react this methane with, if I react methane with this concentrated HNO3, just try what will be the product. Concentrated HNO3. What do you think? What should be the product? Everyone try it out. Try it out. Everyone do let me know what should be. Yes, Bhumi, you are right. Absolutely right. Kids, do let me know what should be the product. So, it's the answer is no reaction. No reaction. No reaction. So, better to say lower alkanes do not react or do not undergo nitration. Do not undergo nitration. Now question arises why? HNO3 is an acid and HNO3 is saying I want to act as an acid, but methane is saying your business is your business, that's none of my business. What can I do? I can't behave as a base. So this cannot act as an acid. And lower alkanes do not undergo nitration because they are not polar. Because they are not polar. They are not polar. But now question arises, why and how higher alkanes they undergo nitration? What is the mechanism? What is the mechanism? See, the mechanism is, suppose if I take butane, CH3, CH2, CH2, CH3, and if I react with concentrated HNO3, at high temperature, at very high temperature. Now, what will happen? One is this substrate and one is this reagent. What is going to happen? See, this substrate, when subjected to high temperature, it will undergo pyrolysis. It will undergo pyrolysis. Now see, before pyrolysis, hydrogens will eliminate out. So what free radicals you are going to get? CH3, CH, CH2, CH3 free radical you will get. Along with this, you will get CH2, 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 CH3 free radical. This is the normal breaking of hydrogen. Now pyrolysis, cracking is going to take place. It will crack from here. You are going to get CH3, CH2, CH2 free radical and methyl free radical, and if it is breaking from here, you will get ethyl free radical. These many alkyl free radicals you have got. Is it okay? These many alkyl free radicals you have got. Now, what is going to happen with HNO3? See to it. What HNO3 is going to experience. Now, you must have seen number of times HNO3 breaking as H positive, NO3 negative, but here free radical mechanism, because high temperature, so homolysis will take place and it will going to get break like this, NO2 free radical and OH free radical. These two will get formed. You must have, I think you have seen or not seen, I don't know, but these are the free radical. Now, we have to do the permutation and combination. We have to do the permutation and combination. Once this question has been asked in NEET or AIMS, that what is the major product during this reaction? This question has been asked. Find out the major product of this reaction. Major product. Now see, this NO2 will attack on the most stable free radical. This is being most stable free radical. This is being most stable free radical. And this is NO2 is going to attack on this, and you will get the product, and that is the most stable product, or the major product, better to say major product. This is going to be answer, and you have to mark this product as your answer. 2-nitrobutane. This is your major product. This is your major product. Major product. Major product. Is it clear to all of you? Now at last, I'm going to give you one memory chart. Okay, Vidhanjani, my data got over. Okay, no problem. Now I'm going to give you one memory chart, and then the session is going to get end up. At last, one memory chart. This is really very important for your all type of examinations. The memory chart I'm going to give you. Here is methane. See to it, everyone. This is your methane. And if I react this methane with Cl2H nu, what you will get? If this methane has been treated with Cl2H nu, do let me know, help me with Cl2H nu, what you will get? Cl2H nu. the free radical substitution reaction. What you are going to get? Everyone do let me know what you are going to get. You will get methyl chloride CH3Cl. What is the name? Methyl chloride, and you have to learn it right now. Now, today we have seen if methyl chloride or any alkyl halide is treated with twice of Na dry ether, what you are going to get? Na and dry ether. What is the name of this reaction? Na dry ether. Whatever we are having will get just doubled. Wurtz reaction, just like Wurtz Khalifa. Wurtz reaction. Wurtz reaction. Wurtz reaction. What are you going to get? You will get CH3 and CH3, double of alkyl halide ascent of series. Are you able to get it? Can you see everyone? Can you see everyone? Let me write down once again whatever I've told you. I want to see whether you are able to understand or not. Do let me know everyone. Are you focusing or not? Do let me know whatever from where I have started. Do let me know from where I have started. I have started from methane, known as Mars gas. Then what I did? I have treated methane with Cl2H nu, that I have written free radical substitution reaction. Then what I got? I got methyl chloride. Then what I did? I have treated this methyl chloride with Na dry ether. What was the name of this reaction? Name was Wurtz reaction. What it was doing? Wurtz reaction, doubling the alkyl halides and it's making alkane. Then what I got? I got ethane, CH3. Till now I've told you this much. I've told you, isn't it? This much I've told you. Everyone is able to understand. Then what I did? Nothing. Now I am going to write a chlorination of it. Cl2H nu. What I will get, kids, do let me know. Free radical substitution reaction. What I will get? I will get CH3 CH2Cl, ethyl chloride. Then what I will do? Now let me treat this ethyl chloride with alcoholic KOH and aqueous KOH. Two types of KOH I am going to react. One aqueous KOH, one alcoholic KOH. Kids, focus over here. Once I am writing KOH, alcoholic and heat. Another one I am writing KOH, aqueous. There is difference. Whenever I am taking aqueous, it is going to do nucleophilic substitution reaction, and alcoholic will do elimination. Always remember that, elimination. So on elimination, I will get ethane, CH2, double bond CH2, and over here I will get ethyl alcohol, CH3, CH2OH. Now, if I treat this ethane with reddish brown bromine water, you know, bromine water color is reddish brown, Br2 water. Now, reddish brown water will get decolorized. The water will get decolorized, and the product will be CH2Br. Now, what is the name of this product? Ethylene bromide. So its name is really awesome. Ethylene bromide. It is vicinal halide, ethylene bromide. no double bond is there, no alkene is there, but then also its name is ethylene. Do remember journal name, ethylene bromide. Now it's given in NCERT that if you react this with alcoholic KOH, alcoholic, what is going to happen? And heat, one bromine will go from here, one hydrogen will go from there, one bromine will get eliminated out from here, you will get delta positive, and proton will get eliminated from negative, then you will get vicinal halide. Vicinal is CH2 double bond CHBr. Now this bromine's lone pair is doing resonance with this compound, so this is vinyl halide. Now you have to take one strong base if you want to do reaction. So soda amide is being taken, NaNH2. Soda amide is stronger base than KOH plus. Strongly heating, once Br will go from here, you will get delta positive and delta negative. HBr will eliminate out, you will get acetylene. Now once you got acetylene, you have to react acetylene with water, but with water it's not reactive, that much reactive, very low reactivity is there. So along with water you have to take 1% HgSO4 and 40% H2SO4 solution. With this you will get acetaldehyde, CH double bond O. Now do the oxidation of this acetaldehyde. On doing oxidation with KMnO4 or any strong oxidizing agent in acidic medium, you will get acetic acid. Now today only I have told you, if you do the soda lime reaction of acetic acid, if you do the soda lime reaction, do you remember soda lime reaction or decarboxylation reaction? This I have told you, soda lime reaction or decarboxylation reaction or lab method preparation, you will get this methane. Now this ethyl alcohol, if you treat this ethyl alcohol with concentrated H2SO4 at 443 Kelvin, concentrated H2SO4 at 443 Kelvin, you will get ethene. This is known as dehydration, acidic dehydration reaction, acidic dehydration. And this is just reverse of, if you add water to it in presence of dilute H2SO4, this is known as hydration reaction. Now in class 12th you will study how to convert alcohol into aldehyde in one step. That is, the best reagent is PCC. The full form of PCC is pyridinium chlorochromate. What is the full form? It is given in your class 12 part 2 332 page. Pyridinium chlorochromate. Pyridinium chlorochromate. Now this is really very important chart, memory chart. Definitely it will change your life. It's 100%, I am telling you, if you do this chart, if you cover up this chart, this is going to change your life. And this was the memory chart, you can say basic memory chart, which for the first time I prepared for myself. And this was the journey from where I have started it now, kids. Whatever I have told you, I will give you just 4 questions, and then this session will get completed with 4 questions, right? So let's see question number 1, question number 2. Whatever I taught you, I will ask from there only, right? Question number 1. Are you ready, everyone? Whatever I have told you, I will ask from there only. Nothing else, nothing more than that. So suppose if I'm saying that I am provided with CH3, CH2 and MgCl. Sorry, kids. And it has been treated with ethyl alcohol. Do let me know what should be the answer. In the chat section, do let me know what should be the answer. Sorry. Srinthi, Santhi Kumar, thank you. Thank you. What should be the answer? Ethane. Janvi, absolutely correct. Ethane will be the answer because this is Grignard reagent. This is Grignard reagent. And this is having active hydrogen. They combine together. C2H6 will be the answer. Now, second question. Question number 2. If you are provided with cyclohexanone and they are treating with zinc Hg plus HCl, what should be the product? What should be the product? Anyone? Do let me know what should be the product. Yes, I am waiting for your answer, everyone. Benzene. No, this is the mistake. This is not benzene. Done. You know the answer, but benzene by chance you have written. It's cyclohexane. It's not benzene. Remember that. It is cyclohexane. It's not benzene. It is cyclohexane. Even though you got the correct answer, but you have marked the wrong answer. Because whenever we see something like this in our mind, always, yeah, Srinath, absolutely correct. Now, third question. Question number 3. Question number 3. See to it, everyone. If I'm provided with CH3, CHCl, CH3 plus H2 plus Zn and HCl, what you are going to get? Let me check it out. What you are going to get? Thank you, Jyoti. Yeah, definitely. Now, do let me know what answer you are going to get. Fast, fast. Everyone fast. Be fast. Everyone, do let me know what answer you are going to get. Let me check it out. What answer? Fast. You are taking too much time. This is given in NCERT that this Cl will go away with this hydrogen, and this one hydrogen will come in the life of this compound, and you will get CH3, CH2, CH3. This will be your product. It's, I've told you, propane. Yes, propane is the correct answer. Now question number 4. This is going to be the last question, last but not the least. Question number 4. Everyone try to answer it. Question number 4. See to it, everyone. I'm going to write it down. If you are provided with CH3, CH2, CH2, COOK, aqueous, and you are going to provide some current to it. Current. Now what will you get? This is the last question for today. What will be the answer? Okay. Should I give you this as the homework? Will you write in the comment section? Homework. This question is homework, and I would like to see the answer in comment section. What you will get at anode, what you will get at cathode. Anode products and cathode products you have to write down separately. I would like to see in the comment section. So kids, really I would like to say that for continuous 6 hours, wow, go hill. For continuous 6 hours, you have studied the complete theory along with questions, along with the tricks. We have not only, I'm saying from my side, we have completed the whole alkane. You must have seen, right, Goelji, absolutely, you must have seen that each and everything we have completed from the NCERT, from whatever the thing. Just now you have to do one thing, do the proper revision. There will be doubts, there will be mistakes, there will be obstacles, but with your hard work and homework, yes, definitely you are going to achieve success. There will be success. Do remember, always do the revision for these particular things on the particular time. Once the time has gone, you can't do each and everything on a single day. So once today we have just gone through alkane, now just when you wake up in the morning, without opening your notes, try to recall what we have studied today about just the alkane. Forget about the past. Forget about the things what's happening around you, because number of chaotic environment will be there in everyone's life. But just when you wake up in the morning, think about alkane, what your teacher HSP Baba has taught you. Just try to recall, just try to recall. You will be able to recall only 20 to 30%, not more than that. Definitely you will feel shame on you. You will feel yourself to be guilty, but don't feel like that, because this will happen to each and everyone. But yes, definitely on another morning, result will be better. You will be able to recall more than 70%, because your mind will always searching for those notes only. And after 2 days, you will be able to recall 100%, and that is the win-win position. Definitely you are going to get that position. I'm telling you, if you do the revision, third day, each and every one of you is going to get 100% clarity. You will be able to see each and everything, means whole notes in the air only, then that day you're not going to ask anyone what to do, how to do revision, which book should I follow, because each and everything will have gone to your, that must have gone to your hippocampus. It's all the best. Good night. May God bless you. Jai Hind. Bye.